எஸ் சார், செஷன் சார் போட்டிருக்கோங்க சார்.
என்னைக்கு அவருக்கு என்னைக்கு
சார் டுமாரோ சார், 20th.
சார் உங்க வாய்ஸ் கொஞ்சம் பிரேக் ஆகுது.
அப்படியா?
ஆமா ஆமா. நெட்டு ஸ்பீடு கம்மியா இருக்குன்னு நினைக்கிறேன்.
அது இன்னைக்கு வீட்ல இருக்கேன். ஆமா இன்னைக்கு வீட்ல இருக்கேன் இன்னைக்கு.
இல்ல அதான் ஏன்னா நீங்க பேசுறப்ப வந்து உங்க
போனதுல கொஞ்சம் சிக்னல் கொஞ்சம்
இல்ல அதான் சரி பேசுறப்ப உங்க இத இமேஜ் ஆஃப் பண்ணிட்டு பேசுங்க. இப்ப கிளியரா வந்துரும்.
ஓகே ஓகே ஓகே.
ஸ்டார்ட் பண்ணிட்டு அப்புறம் வீடியோ ஆஃப் பண்ணிட்டீங்கன்னா கரெக்டா வந்துரும்.
Because no one else is going to do it for you. Great things never come from comfort zones. The harder you work for something, the greater you'll feel.
ಆಮೇಲೆ ಬ್ರೈಟ್ನೆಸ್ ಕೇಳಿದ್ರಲ್ಲ, ಇಲ್ಲೇ ಐತೆ ನಂದ್ರಲ್ಲಿ. ಅವತ್ತು ಕೇಳಿದ್ರಲ್ಲ, ನಾನು ಇಲ್ಲೆಲ್ಲೋ
PSK, please mute all. PSK?
Yes sir, muted sir. Prabhudas sir, you need to unmute பண்ணிக்கங்க. Prabhudas?
Yes, unmuted sir.
Okay.
Push yourself because no one else is going to do it for you. Great things never come from comfort zones. The harder you work for something, the greater you'll feel when you achieve it. Department of Mechanical Engineering and Department of Civil Engineering, Sri Sairam Institute of Technology heartily welcomes one and all for the AICT sponsored third virtual international conference on materials, manufacturing and mechanical engineering for sustainable developments, ICMSD 2020. A hearty welcome to everyone. We extend our special welcome to our chief guest, Dr. V. Balasubramanian sir, Professor, Head and Director in CMJ and RE, Department of Manufacturing Engineering, Annamalai University, Chidambaram. Welcome, sir. So we extend our welcome to guest of honor, Dr. Ezuta Udansiolugu, Department of Technology, UCSI University, Kuala Lumpur Campus, Malaysia. Welcome, sir. We also extend a hearty welcome to our beloved principal, invited keynote speakers, invited session chairs, head of the departments, participants, faculty members, and dear students. God is the source of everything. He is the beginning and he is the end. In him is hidden the treasures of knowledge and wisdom. Let us invoke the blessings of God Almighty to be showered on each and every one of us during this occasion and in all walks of our life. Here we have a short promo video on our international conference ICMSD 2020. I request each and every one of you to have a watch on the promo video, please. Thank you. ICMSD 2020 at another milestone in the technological path of Sri Sairam Institute of Technology. Our beloved principal, sir, Professor Dr. K. Parnikumar, an experienced professor with a demonstrated history of working in higher education industry, skilled in statistical data analysis, lecturing, curriculum development, and public speaking. He is one of the international experts in composite materials, having organized many national and international conferences, faculty development programs, having more than 5,000 citations with the credit of publishing more than 160 articles in SCI and Scopus Index journals. He has received a grant and aid of around 1.5 crores from various funding agencies. So far, he has published 15 patents and received many meritorious and best faculty awards from various governing bodies. So we are happy to welcome our beloved principal, sir, Dr. K. Parnikumar, General Chair and Convener of ICMSD 2020 to deliver the welcome address. Please, sir.
Sir, kindly unmute yourself, sir. Sir, kindly unmute, sir.
Okay, very good morning to one and all present here. So I hearty welcome one and all for this August gathering. So this is another one milestone in the Sairam Institute of Technology history. Sri Sairam Institute of Technology is only started in the year 2008. Within the 12 years, we have got NBA for almost all the program, and also we have got NAC accreditation with A+ grade, and also we are in the top 200 positions in the National Institutional Ranking Framework. The only college in Tamil Nadu which is having 12 years of experience achieved all those things. I extremely happy to render my sincere thanks to our chairman for providing an opportunity to have this international conference in our Sri Sairam Institute of Technology. So this is the All India Council for Technical Education sponsored conference. Actually, we are conducting this international conference that time. Previous two conferences we have already conducted, but this year we have planned to conduct this conference through in friend mode, but due to the pandemic situation, so we have shifted this to the virtual mode. So because of that, this conference is happening in the virtual mode. Almost all the paper, those who have been accepted for the presentation will be published in the materials today proceedings. There is a elsewhere publication with Scopus syntax. So this is the third virtual international conference on materials, manufacturing, and mechanical engineering for sustainable development, ICMSD 2020. We are going to have this conference for 2 days, Thursday 19th November and Friday 20th November. So we are conducting this conference through Zoom ID with password. So in this August gathering, eminent professor and eminent personality in materials, the expert in welding technology, even he is my mentor and teacher. He has accepted our invitation, for which first I extend my sincere thanks to him. I cannot express about his experience and projects and other thing about in words, because the manufacturing engineering department in the Annamalai University is having lot of funds, awards, many things. Only this is because of our professor, Dr. V. Balasubramanian. So he's contributed to the world in many occasions, and also he is one of the top 2% researcher in the scientific world indicated by Stanford University on materials. So his contribution to the world is immense. Even though he has preoccupation, immediately he has accepted our invitation, for which I extend my sincere thanks to him. On behalf of our management, on behalf of our faculty members, and also on behalf of our organizing committee and the students, I warm welcome you, sir, with your blessings, sir.
Thank you.
Also, I warm welcome our guest of honor, Dr. Elutha Udonsi Olugu. She is the Associate Professor in the Department of Technology, UCSI University, Kuala Lumpur campus, Malaysia. He has vast experience and previously he has worked in many international universities. Now he is working in the UCSI University. So he has a very experienced professor handling many classes for the benefit of the students. So even though he has preoccupation, he has accepted our invitation. On behalf of our management, also on behalf of our faculty members, organizing committee, we warm welcome Dr. Elutha Udonsi Olugu, Department of Technology, UCI University, Kuala Lumpur campus, Malaysia, for our international conference, ICMSD 2020. Also, I warm welcome the distinguished keynote speaker from Malaysia, Dr. Ilango Natarajan, Department of Technology, UCI University, Kuala Lumpur campus, Malaysia. He is going to present a keynote lecture on the topic, can machine learning reduce the wastages and increase the productivity? Also, I warm welcome Dr. I.A. Palani, Dean, Research and Development, Mechanical Engineering Department, IIT Indore. He is going to give a keynote lecture on laser and smart material key elements in advanced manufacturing. Also, I warm welcome Dr. Ganesan alias Muthusamy, Department of Technology, UCSA University, Kuala Lumpur campus, Malaysia. He is going to give a keynote lecture on manufacturing excellence by adopting quality management principles. Also, I warm welcome our revered Professor Dr. B. Mohan, Department of Mechanical Engineering, Anna University, Chennai 25 as a keynote speaker, and he is going to present a lecture on nanomaterials for sustainable development. Also, I warm, on behalf of the organizing committee, I warm welcome our distinguished chairpersonals, Dr. K. Sanmusundaram, Professor, Engineering Design Division, Anna University, Chennai, Dr. V.S. Senthil Kumar, Professor and Head, Central Workshop, Department of Mechanical Engineering, Anna University, Chennai, Dr. K. Sanmugam, Department of Manufacturing Engineering, Annamalai University, Chidambaram, Dr. T.V. Rajamurugan, Department of Mechanical Engineering, Government College of Engineering, Trichy, Dr. S. Ramesh, Department of Mechanical Engineering, Presidency University, Bangalore, Dr. S. Balasivananda Prabhu, Professor, Central Workshop, Department of Mechanical Engineering, Anna University, Chennai, Professor T. Rajamohan, Department of Mechanical Engineering, SCSVM University, Kanchipuram, Dr. S. Prakash, School of Mechanical Engineering, Satyabama Institute of Science and Technology, Chennai, Dr. V.K. Bhubesh Raja, Department of Automobile Engineering, Satyabama Institute of Science and Technology, Chennai, Dr. Krishnamurthy A., Department of Mechanical Engineering, Satyabama Institute of Science and Technology, Chennai, Dr. K. Swakumar, Department of Mechanical Engineering, SRM Malliyamai Engineering College, Dr. Anbu Chalian, Department of Mechanical Engineering, SRM Malliyamai, and Dr. T. Rajasekaran, Department of Mechanical Engineering, SRM Institute of Science and Technology, and Professor B. Vijay Ramnath, Department of Mechanical Engineering, Sri Sai Ram Engineering College. Also, in this August gathering, I warm welcome all the organizers of this event. So they have did wonderful work for the benefit of the scholars and the researchers in the field of materials manufacturing and the related one. Also, I warm welcome all the professors, teachers, and the students from Sri Sai Ram Institute of Technology, and all the participants, those who are participate through the Zoom meeting. I warm welcome on behalf of organizing committee, one and all, for this August gathering. So this 2-day deliberation, so we are able to have the discuss many things, so that the presenters and the researchers are able to get benefit from each other. So this is a great forum for interaction, so that we will have more interaction and we will have to excel in our life, and also this type of conference should be benefited to the society, so that we are able to have something for the society. So thank you, Anandal. Thank you very much for the opportunity. On behalf of organizing committee, once again, I warm welcome Manandal for this August gathering. Thank you very much. Thank you for the opportunity. Thank you.
Thank you, sir. Thank you for the warm welcome. A wise man is of more strength and more power. We are happy and privileged to have Dr. V. Balasubramanian, sir, to be our chief guest for today's inaugural function. Dr. V. Balasubramanian, sir, top 2% scientist in materials, professor, head and director in CMJ and RE, Department of Manufacturing Engineering, Annamala University, Chidambaram. He is specialized in materials joining and surface engineering. So he has guided PG scholars of about 20 and more than 22 PhD scholars so far. He has conducted, organized, and attended more than 40 national, international conferences, seminar, symposia, and workshops. His research projects includes a worth of 700 lakhs of 25 major projects completed so far, and currently he is working on 3 major projects. He has a rich teaching and research experience of 27 years. His research projects are worth rupees 700 lakhs of 25 major projects, and currently he is working on 3 other major projects of worth 340 lakhs. He is an active member of IWS, IIW, ISTE. So we are happy to have you, sir. So we kindly invite you to deliver the inaugural address. Please, sir.
Thank you for brief introduction. Good morning to all. So I am very happy to participate in the third international conference on materials, manufacturing, and mechanical engineering for sustainable development. It's really a wonderful opportunity to the participants. First of all, I would like to thank the principal and my close friend, Dr. Palani Kumar, for giving me this opportunity to deliver another address in an international conference, that too through the virtual mode. Of course, I have seen this promo video. It was really wonderful to see that the previous editions of this conference in the physical mode, because now we are always missing the flavor of the physical mode. Because now when you go for a physical mode of organizing conferences, there are a lot of flavors will be added into the organization, and a lot of people physically you can meet each other, and you can exchange the greetings each other and the blessings each other. But now we are missing that flavor. Of course, one way it is beneficial, because now we are all sitting comfortably in our places and in our houses or in the offices, and we are taking part on this international conference. And it is really a great effort by Dr. Palani Kumar and his team, and they have, even this very challenging period, pandemic period, they were able to mobilize nearly 100 participants. And I came to know through Dr. Palani Kumar that they have received 100 papers in a short span of time. It's really wonderful, because another highlight is all the papers, accepted papers, will be published in the Materials Today proceedings, one of the Elsevier publications. That too, it is indexed in the Scopus database. So it has many reasons for the importance. And I would like to congratulate all the organizing committee members, the coordinators, and Dr. Palani Kumar's team for making this effort to disseminate the knowledge, or disseminate the recent advancements that are taking place in the materials and manufacturing and mechanical engineering. If you take the mechanical engineering, it's like a ocean. So the mechanical engineering generally will have different divisions. One of the major division in mechanical engineering is the manufacturing, and then the materials. And materials and manufacturing will go hand in hand. And this materials, of course, in the universe, if you take the universe as a whole, all the substances will be comes under this category. But the substances are classified into two groups. One is called living substances. Other one is called non-living substances. So living substances, the human being, the animals, the birds, the trees, those who are in living organisms, so they are called as the living substances. But there are plenty of non-living substances. So the non-living substances normally, generally called as the materials. So in the non-living substances, again, it's as I told, there are materials, as I told, in the universe, if you as a whole, if you take plenty of materials are there. Some of the materials are explored. Many of the materials are not explored even today. And the scientists, metallurgists, and mineralists, they are all exploring newer materials, and they are developing newer alloys or newer materials for their applications. So every day, this field, especially this field, is changing one, and it's like IT field, information technology field, the material science field also. It is a changing field, and every day the new inventions and new developments and new novel materials are coming up. And it was all the credit goes to the people, the scientists, those who are working on materials engineering field. The material science and engineering, so if you say that, so it's a materials as a whole, you have three classifications. One is called as the metals and alloys, you're all aware of that. And another classification comes under the, what do you call it, is the polymer materials, polymeric materials, and then you have the ceramic materials. So these are the three broad classification comes under the materials. Metals and alloys, we always normally we used to refer metallurgy, the science which is dealing with metals and alloys alone will be called as the metallurgy. But material science is the let's say the metallurgy is subset of material science. There are other two divisions, which is known as the ceramic materials, and then the ceramic means ceramics and glasses, and then you have the third category, it's polymers and rubbers. So all the three put together, metals and alloys, ceramics and glasses, and then you have the polymers and the rubbers, they all combinedly called as the materials. So in those materials, you have a lot of developments that are taking place nowadays. And I can quote many examples even today. A few days back, our Prime Minister visited the Jaisalmer, the Rajasthan border, and he celebrated Diwali with our soldiers and our army people. And he also had a drive on our tank, indigenously built Arjun tank. So Arjun tank that was built by our own DRDO scientist, and it is in Chennai. There is a factory, it's a R&D lab, which is called as the CVRD, Combat Vehicle Research and Development Establishment. They only designed and developed that Arjun tank, Arjun battle tank. And the side by side, we have the heavy vehicles factory. There it is, the tanks are manufactured. Why I am saying this is, so that tank, so now it is made up of a steel called rolled homogenized armor steel, RHS steel. That's called the rolled homogenized armor steel. So that steel is stronger than 4 times stronger than the conventionally used mild steel. The mild steel, you all aware that, which is widely used in the structural fabrication. But this armor steel, this is also steel, but it has the properties much better than the mild steel. So the rolled homogeneous armor steel, which is used in the construction of the battle tanks, which requires a high hardness, high toughness, and high yield strength. This is a combination of three properties. It is very difficult to achieve all the three properties: high hardness, high toughness, and high yield strength. So if you take this armor steel, rolled homogeneous armor steel, which is having a yield strength of 1200 megapascal, 1200 megapascal. And if you take the hardness of the armor steel, which is having a hardness of 400 to 450 Vickers hardness, and then if you take the toughness, it will be around 50 joules at room temperature. So it's a combination of these properties. It is difficult to achieve because these properties is required. Then only you will get the ballistic resistance. But now, what are the Arjun tank which was made by these steels, using these steels? Now they are moving for the next generation combat vehicles. So they are planning to use a steel called ultra high hard armor steel. What is this ultra high hard armor steel? As I told, no, the armor steel which is used presently in the battle tank, the Arjun tank, is 1200 megapascal. The steel which I am referring, which is called UHA steel, ultra high hard armor steel, having a strength of, you cannot imagine that it is having a strength of 2100 megapascal. 2100 megapascal. So just you compare, the mild steel is having a strength of 300 megapascal, and even the rolled homogeneous armor steel, which is used in the Arjun tank, is 1200 megapascal. But the futuristic tank will be utilizing this ultra high hard armor steel, which is having 2100 megapascal, 7 times stronger than the mild steel, and twice the strength of the present armor steel. And if you see the hardness, it is 600 BHN. The hardness is 600 BHN. So that is the steel is having. And the toughness is not, it's not much high, but it is equal to the toughness of the present armor steel of 50 joules. So the metallurgists, they are playing with the chemical composition, and they are playing with the heat treatment processes, and they are making the steels. They are developing the steels. This steel, even the steel was developed indigenously. Our DRDO has developed. It is called DMR 1700 steel. It is in Midani. There is in Hyderabad. There is a center called Midani. So the Midani is developing this steel, and it is 17 DMR 1700 steel. So the development, by varying the chemical composition, by varying the heat treatment process, they were able to develop the very high hardness, high toughness steels. So why I am telling this one example is, we are working on this project, and the main challenge is the ultra high hard armor steel is machining of the steel. Okay, machining itself is a problem, big problem. You cannot machine just like that. You cannot use any, even the carbide tools will fail. And another problem is forming of the steel, metal forming, any metal forming, it is difficult. And then finally the assembly, the fabrication, the welding also difficult, because the carbon content is high in the steel, the carbon equivalent number is very high in the steel. So we are working on that to develop the welding procedures, weldability studies, we are doing it, because in the future, maybe in another 10 years, we have to utilize the steel in the battle tanks. The reason is they want to reduce the weight of the tank. The weight of the tank should be, now it is comes around 68 tons. The present day Arjun tank is, the weight of the whole tank weight is 65 tons, but they want to reduce below 50 tons, sub 50 ton tanks, which can be transported through the air. That's a flight. Through the flight, they want to transport to the terrains. So that's the reason they are looking for the steel. Steels were developed, but the problem is manufacturing methods are not developed. So like that, there are many examples I can quote. And even I was wondering, because in India is leading in the material science research. I can quote one small example. Recently, the Nature journal published one report on the recent the things. You all hear, the people, those who are from Tamil Nadu, hear that near Madurai, there is a place called Kiradi. This Kiradi their archaeology department is doing research on Kiradi. So in that Nature journal, there was a report. The potteries used by those people know it is 6th before Christ. 6th century people, before Christ, 6th century people, they used potteries. That potteries, the inner side, there was a coating. That coating, some of our people, Aragappa University scientists and other Madurai Kamaraj University people, they have investigated the pottery, the pieces, and they found that inside, not outside, the inside they found that there is a carbon nanotubes coating of carbon nanotubes. It's not multi-wall carbon nanotubes. It is a single-wall carbon nanotubes. We don't understand. Even the authors they told that it is not able to understand how whether they had a technology to coat the carbon nanotubes. And it is what it's a pottery items. What it is a ceramic material, and the ceramic material they have given a coating. So inside the parts there is a CNT coatings, carbon nanotubes coating, that too single wall carbon nanotubes coating. They have given the beautiful pictures using TEM, FESCM, and XRD, all the evidences they have produced. So I'm wondering, because no, you just imagine before Chris, during 6th century, okay, our people, even our own Tamil people, are very good in the materials science. That's why I want to tell this one example for that. So there are a lot of scope for the research and also for the development for the material scientists. Not only this, whatever I told, no, metals and alloys in metallurgy, also in the ceramic materials field. In ceramics, no, there are the requirement for the even in the people and the gas turbine. You heard about gas turbine, which is the prime mover for all our space program. And there is a center called the Gas Turbine Research Establishment in Bangalore. It's also DRDO center. They are developing indigenized gas turbines, Kaveri program, Kaveri engine program. So there, there are they are using titanium alloys and nickel-based alloys for the gas turbine, the manufacturing of gas turbine components. But even that nickel alloys and the titanium alloys, if you want to improve the efficiency of the gas turbines, then you have to operate the gas turbines at high temperature. And that high temperature, now they are operating at 1100 degrees centigrade. So they want to improve the temperature, operating temperature to 1400 degrees centigrade. Then only the efficiency of the engine will go up. So for that, they are giving coating, thermal barrier coating. We used to say it is a TBC, thermal barrier coating. The thermal barrier coatings they are giving using the ceramic materials. So a lot of ceramic materials are there, and yttrium stabilized zirconia. It is one type of ceramic material which is normally used for the TBC applications. But this TBC, that yttrium stabilized zirconia, is able to withstand a temperature of 1200 degrees centigrade only. Beyond 1200 degrees centigrade, it destabilizes and metallurgical changes are taking place. Because of that, the coatings, the TBC coatings are peeling off. So now they are working towards developing the 1000, you have to withstand 1400 degrees centigrade. They are working towards developing lanthanum zirconate and the rare earth dope thermal barrier coating. So that is another field, that's a ceramic field. The work is going on. And even in the magnetic materials, even in the electronic materials, right? The revolution which is taking place in the IT field, we are responsible. The material scientists are responsible, and manufacturing engineers are responsible. Whatever they do, whatever they can code, they can program, but without a component, without a device, you cannot do anything. If you take manufacturing, there are even if you develop the materials, if you say it's even the present day mobile phones and the Android phones, all those things, it is all what it's electronic gadgets and electronic materials. Even those materials are processed by micro machining, nano machining. So these are the order of the day. Even a few days back, I delivered a lecture, micro machining by lasers. So micro machining by lasers, now we are working towards femtosecond lasers and the nanosecond lasers and picoseconds lasers. So that's the short pulse lasers than the long pulse lasers. So there are a lot of developments taking place in the manufacturing side also, not only the machining, not only the welding, not only the forming. So there is a lot of changes, a lot of developments that are taking place because we have I want to convey this message to all the young researchers, young participants. There are plenty of scope for the manufacturing engineers is concerned because the materials are developed by the metallurgist, the materials are developed by the physical scientists, materials are developed by the chemistry people, so that those whatever the material they develop, that material should be put into use. That will be possible only if you develop a proper processing technologies. Processing technology means it may be the primary sites technology or secondary technology. The call it's in the like the farming processes, and machining processes, and joining processes you have developed. Then only you can design a device, you can design an instrument, and you can make the instrument or you make the device is workable. And to make the end use device, what are the material the people develop? If it is not applicable for the engineers, if it is not used in the application, then there is no use of developing materials. As I told in the beginning, there are plenty of materials are developed day by day, and not all the materials are useful. Even if you take nanomaterials, there are still issues are there. People talking about in nanoscale, if you reduce the the grain size or the size of the particle to the nano size, and you will get enormous advantages. But it's not so in all the cases. It is not so in all the cases. It is only possible in the few cases. There is you have both positive effects, you have the negative effects also. Some material will behave excellently, and some material they will lose their property when you go to the reduce the size of the particle. So the nanomaterials is another area people are working. So there are many. It's like a ocean. So materials is a ocean. In that materials, the manufacturing process is a must, because when you just developing materials is not sufficient. You have to process the material by different methods. Then only you can get a useful product. Once if you get the useful product, then only it will come into the and it will be useful to the society, and it will be useful to the scientific community. It will be useful to the nation as a whole. So I hope that these 2 days deliberation, I went through your brochure, and there are a lot of stalwarts are there. A lot of young people are also in the session, and many papers are useful papers. I request all the participants to interact. No, it's many times. No, I came to know that the participants just registered, even they are not presenting the papers. And because no, once you pay the registration fee, that will be considered for publication. So you are satisfying with that. So don't do that, because why I am saying is we required a lot of people to work on this. We have plenty of problems. We have a lot of challenges in the materials and manufacturing side, and it cannot be done by one person like me or even Dr. Parni Kumar. He told me, no, he introduced me. He is the top 2% in the scientists. Not only me, and Dr. Parni Kumar also following me, and his name is there in the list in the materials field. We are really, no, we didn't know all these things. I know about my number of papers and index, all those things in the scopus, but we never know about our ranking, all those things. Even the Parni Kumar asked me about the sources, all those things. I am not bothered about the rewards, recognitions, and all the other things. We are working for, because I love this profession. I love this profession, teaching profession and research profession. So without expecting anything, we are working as long as we can, as long as we have energy to work, we'll do the work. And not only it's one Balasubramaniam or one Parni Kumar is not sufficient. We need a lot of people like us, and then only there are people like Dr. B.S. Kumar and from Anna University, and even Shanmu Sundaram from Anna University. I have seen many people on the list, and Sivananda Prabhu. There are a lot of young people, even from our Anna University. Dr. Shanmugam and Mr. Dr. Ramesh from Bangalore. So many people are there. So the only thing is the young people are a little bit lazy and a little bit lacking in those passion for doing research. What we had some 20 years back, that was lacking with the present day researchers, research scholars. And if you do really quality research, that will be recognized. Please don't do PhD or research only for getting a job or getting for monetary benefit or only for getting promotions. That's not like that. Even I wonder, Dr. Parni Kumar knows I am only professor here. I'm not doing any administrative work in Annam University, but I am able to do research. But I wonder, I used to wonder how Panic Marma is managing both the administration and research, because it is two different extremes. Administration is different and the academic or research is different, but he is balancing and he is doing wonderful. So on this occasion, on behalf of all the participants, I want to congratulate Dr. Panikumar for this achievement, because sitting at a private college and doing administration as well as the research, that is very, very excellent. And I request all the participants, those who are online, nearly 150 participants in this on the list, it is there. Out of 150, you leave out the organizers 10 people. The remaining 140 or even 100 people, young minds, you should take the role model as Panic Kumar as role model, and you need people. No, we need a lot of people to work. Real people, honest people, sincere people. We need. Then only we can keep our country ahead of all other countries in not only on materials field, even in the manufacturing science field. So I wish all success to this 2 days virtual international conference, and I hope I request all the participants, please interact with the session chairmen or interact with the presenters. Ask few questions, at least 1 or 2 questions you should ask. That is very, very important. You listen to them and clarify your doubts and interact with them. That is the real success of this type of conferences. I wish all success to the conferences. I once again thank the organizers, and special thanks to Dr. Pani Kumar for giving this opportunity. I declare this virtual 2-day international conference open from now onwards. Thank you, and thank you once again for the opportunity.
Thank you, sir. Thank you very much, sir.
Admire your concern and passion for research. Thank you for gracing the occasion, sir. Knowledge knows no boundary. We are happy and privileged to have Dr. Ezuta Udansi Olugu as our guest of honor, Department of Technology, UCSI University, Kuala Lumpur campus, Malaysia. Dr. Ezuta has pursued his PhD in mechanical engineering from University Technology Malaysia. His professional qualifications includes Chartered Engineer in Engineering Council UK, member the Institution of Mechanical Engineers UK, graduate member Board of Engineers Malaysia. His administrative positions includes IPT Evaluation Panel for my grant in February 2019, member Faculty of Engineering Management Board in November 2019. So he has a rich teaching and research experience of around 20 years. His publications includes 2 in book chapters and more than 25 in international conferences and more than 40 in international journals. His awards and recognition IEOM 2016 conference Best Track Paper Award at the 6th International Conference on Industrial Engineering and Operations Management, Kuala Lumpur, Malaysia in 2016, 2015 IP, an expert system for performance assessment and strategy selection for sustainable manufacturing in manufacturing engineering. Best Paper Award at National Conclave Conference on Sustainable Supply Chain Capabilities of Micro, Small and Medium Enterprises, and so on. He has guided around 10 research scholars so far. The grants attracted includes design and analysis of intersectoral green supply chain performance measurement expert system, Malaysian ringgit of 67,200, investigation of influence of different sustainable supply chain network topologies on manufacturing performance within the SEMES, Malaysian ringgit of 1,34,000, and so on. We are happy to have you, sir, and looking forward for your special address. Please, sir.
Good morning, all. It's my pleasure to be in this conference this morning. I really appreciate the the invitation that was extended to me to be in this conference, and I really like the theme of the conference because it's talking about manufacturing, mechanical, and material engineering in sustainable development. So I really because of the short notice actually, so I'll just give a very brief address or speech. So in engineering, we know that the sustainable development goals or sustainability is actually an engineering responsibility. People have actually come to realize that without engineers, you cannot achieve the sustainable development goals, because engineering is actually the vehicle that drives the SDGs towards attaining the goals. Because without engineering, it will be very impossible to actually achieve these SDGs. First, we know what is sustainability or sustainable development. Sustainable development means you have to come up with a developmental plan that will meet the need of people today, and also meet the need of people tomorrow without jeopardizing any of these people's approach or the ability to achieve their needs. So in that case, engineers actually have the main responsibility of ensuring that these SDGs actually are being achieved. Because if you look at the SDGs, we have different goals, up to 17 goals, which you can actually summarize into about 7 goals. If you summarize it into 7 goals, you have the people, you have prosperity, the planet, then you have partnership, you also have dignity. All these things are what makes up the engineering discipline. Then coming back to the engineering discipline as a whole, engineering actually involves principles of science and technology, using them to actually fulfill needs. So in this area, we find out that engineering as mechanical engineers, because I believe material engineers, manufacturing engineers, they are all mechanical engineers. So mechanical engineers actually are at the helm of affairs. Why do I say this? Because when you look at people, you find out that the environment is made up of a lot of products. Who are the people making these products? These products are made by engineers. Which engineers? Is made by manufacturing engineers who are mechanical engineers. What do they use in making these products? They use materials. The evolution of materials have gone into different space. There has been a lot of changes and a lot of evolution in development of materials. Nowadays, people are looking at materials that will save energy, materials that will be recyclable, that will be reusable, that will actually fulfill this SDG. There's no other person who is more qualified to talk about SDGs than the material engineers. You talk about also manufacturing. Manufacturing, how do we know that manufacturing actually is really what moves the world? So without the manufacturing engineers, how do you care to take care of all the planet, all this? Because like I said earlier, the planet is one of the major areas where the SDGs are actually combined. So without the manufacturing engineers, it will be very difficult to come up with processes, with products, with a lot of things that will help the engineer or help the world to actually stay in focus about the SDGs. So we also will talk about, if you look at also different approaches based on these SDGs, the true meaning or approach of mechanical engineering in its entirety has actually changed, because nowadays it's no longer business as usual. Now people have to do engineering work through the lens of SDGs, because you can no longer do things the way it used to be, both in the area of environmental pollutions, both in the area of materials, because now everybody wants a material that will be recyclable, biodegradable. So these are some of the things. So you look at these things, so the SDG as a whole is a big challenge to engineers, especially those from the mechanical extracts. So because of this, we look at the areas, what the implication of these SDGs is to engineers. So one of them is engineers must be very preventive. They must be very preventive in their thinking, meaning that their thinking should be towards how to actually protect the environment. They must also be proactive because now it goes beyond the SDGs. We have to think ahead, trying to come up with a lot of ways of doing things that will help safeguard the environment. Engineers also must be preemptive in their thinking and also in the way they are doing their both research and also in their production, everything that has to do with the engineering. These SDGs also imply a lot of radical changes in the way engineers actually play their roles in the society. We already have a lot of obligations for an engineer, which is enshrined in the engineering books, whether you are, I believe, as a registered engineer anywhere in the world, you have some obligations you owe to the society. Now the SDGs have actually compounded these obligations to with some other things, which includes these environmental issues, making sure that the world have generated a lot of prosperity. Like if we look at also the world itself, you find out that most of the things that drive the society is actually laying back on what the capability of the engineer is, especially the ones in the manufacturing sector. Because manufacturing is one thing, and also we look at, if you look at the people, the other thing is the people. The way people reason actually depends on what the engineer has the ability to control the people. In fact, the engineer is the one that creates the people, the smart people. We call them, let me say, the smart people. The smart people is the responsibility of the engineer, because with the smart devices and the smart apparatus, which are being made available to the people, so the people can actually reason and act in a very smart way and also fulfill most of these SDGs. Then engineers also must integrate sustainability into the mainstream engineering thinking and actions. How are they going to do this? Whether you find yourself in the shop floor or job floor doing regular manufacturing or production, whether you find yourself in the walls of classroom, whether in the research lab, doing whatever you're doing to boost engineering discipline, you have to actually incorporate sustainability into your processes. How do you incorporate sustainability? We know that sustainability involves three broad categories or three broad aspects: the economic, the social, and the environmental aspect. How, if you look at it in a bigger way, is just talking about making profit at the same time, making sure that the people or the society is well taken care of, and also the environment is protected. So if we look at all these three things in our research, it gives us a better view on how we can actually achieve most of these things. This thing, like I say, for me, the way I see it, I think engineers should develop passion for this sustainability, because sustainability is no longer something we talk about whether it will work or not. Nowadays, it's something that is imperative on all engineers to look forward and also work with it, integrate it in your thinking, integrate in your operation, in everything you do, to ensure that you carry this tree burden along with you. Then we also have to look at the natural resources around us. How do we come up with designs, models, and how to actually ensure that these resources are taken good care of in the way that they will ensure and promote these SDGs. The SDGs, when you look at it in a broad category, yes, they are quite large. That's about 17 goals. But if you really look at the SDGs critically, you find out that they actually can be summarized into something smaller, which will be more easily manageable. So I believe most of these things are the responsibilities of the engineers. Like I said, Engineering as a whole is the vehicle that drives sustainability. Without engineering, it will be very much difficult. Inside engineering, we talk about mechanical because mechanical, where, like I said, manufacturing, materials, and other forms of engineering, energy, all these are all under manufacturing, or under mechanical, which means mechanical engineering actually bears the higher brunt of the responsibility of SDGs. Then there should also be this interdisciplinary approach, which every engineer should look at. How do you collaborate within your, if you're in the institution, if you're in the industry, how do you collaborate within and outside your organization to ensure that you work on things that will actually make meaning to the society, that will add a lot of value to the society. These are some of the challenges that the SDGs have imposed on us as engineers, and we must also embrace these challenges, embrace up and embrace these challenges. And instead of seeing them as constraints, we should see them as opportunities, which will now usher us into the new engineering world. So, and if you look at some of these, things, some of the areas we have already looked at. So some of this, like I said, I don't really have a very long presentation. I just wanted to make a very brief presentation. So engineering as a whole has a lot to do. It has a lot to do. We have to all go back to the drawing board, see how we can in our various disciplines within the engineering field, and map out how can we actually incorporate this sustainability into our researches, into our production, into our energy generation, in every aspect of engineering, especially the mechanical, because this conference is a mechanical engineering and civil engineering gathering. So I believe most of these engineering disciplines have a lot to contribute in making sure that engineering and all these SDGs are achievable. And also there are some of the things I look at, like the areas I've identified that engineers can actually work on. Some of the areas include the transport systems, coming up with more efficient transport systems, eliminating the negative environmental effect of the transport systems, then facilitate urbanization, and also promote rural integration and sustainable development. We also have to look at infrastructures. How do we come up with infrastructures that will have a higher longevity? Because nowadays it's about, when you talk about the economic aspects, so we have to talk about infrastructures that have a higher lifespan, and also the maintainability will be less in terms of cost. Then we also have to look at these things in terms of the resource development. When you look at resource development, which like Prof just talked about now, we look at materials. How do you plan? You have to plan and also plan and promote environmental conscious and efficient material use, both from the mining on, from the development, processing, all this, you have to look at it. Then sustainable water resource planning is also a major area which has to be looked into. Then we enhance operation in drainage systems, efficient farm management. All these are areas that should be looked into. We also have to enhance the use of resources. The use of resources from the recycling, reuse, remanufacturing, all these areas we have to look at it. How do we make them more efficient? How do we make them more attractive? These are some of the things we should be able to do as engineers. Then engineers also owe the world, like I said, they owe the world this channeling the drive for these sustainable development goals. And one of them is also in the area of environmental control. Environmental control in terms of monitoring environmental control, managing industrial waste, all these things comes into the purview of the engineers, especially the manufacturing engineers or the material engineers. And also we look at the area of industrial collaboration. collaborating with other various industries to come up with solutions that will better and make it easier to achieve these goals. Then in the area, one key area also that engineers, I've already mentioned a little bit, I find out that engineers, when it comes to reuse and these recycling processes, engineers have a lot of role to play. It's high time the engineers took it upon themselves. It shouldn't be something we leave for people in the street. We should take the lead. We should take the lead in the recycling and reuse of materials. We should look at it, come up with frameworks that will actually enhance efficient recycling. Because nowadays you can recycle, yes, but the issue is the recycle process really efficient? How to ensure that we have higher recoverability? Also ensure that the emissions that are occurring during this recycling process, they are actually quite minimal. So these are some of the areas, even in the terms of the material selection. When we are selecting this material, we have to ensure that these materials will make easier recycling processes. So the other aspect is actually in terms of energy efficiency. Energy efficiency is something that is very, very important. Nowadays, engineers are working on different aspects of research to ensure that energy efficiency is actually achieved. And I find out that this is actually, when you basically this is a mechanical engineering is a mechanical engineering problem or challenge. So we as engineers should be the one championing this energy efficiency, whether be it in the designing, redesigning of industrial layouts, industrial facilities, residential buildings, or even in the area of equipment, such as the air conditioners, the refrigerators, lighting systems. All these are things that the engineers should actually be spearheading, especially the mechanical engineers. So the other aspect is actually in the area of sustainable IT. So if you look at the world as a whole, the world is tending towards more digitization. So we as engineers, we also have to lead the way. And as mechanical engineers, we have to also make sure that we come up with ways and strategies on how to digitize the world. I have a lot of, there are a lot of mechatronic designs coming up, mechatronic research going on that will ensure these things are attainable. They also need to develop tools and machineries that can enhance sustainable development. At the same time, there's need to network with the nature and redesign products into services which will enhance the creation of prosperity or wealth among people, which is actually one of the #1 goals in SDGs. So the conclusion of my talk actually is that engineers are the vehicles upon which sustainable development thrives. And engineers actually, they are the ones who initiate and promote SDGs. They actually steer the direction of this sustainable development, because without the engineers, it's very, very difficult. So we engineers, we have to brace up and embrace the challenge as the key or the forerunners on this SDGs. Finally, I say without engineers, it will be very impossible to attain the SDGs. Thank you.
Thank you, sir. Thank you for accepting our invitation, sparing your time, and giving a brief information, sir. Thank you. Thanks a lot, sir. So I request all the participants to switch on your video. So as this is a virtual platform, we like to have a group photo, a photo session now. So I request everyone on the meeting bridge to switch on your video, please. Kindly switch on your video. Dr. Shanmugh Sundar sir, kindly intimate us, sir, if the video, the photo has been taken.
Okay, thank you all. Thank you, sir.
Thank you.
Prabhudas
Thank you,
sir,
everyone. Yes, sir.
keynote
Yes,
speaker
sir.
will be also there.
Okay.
Some sir already in line.
Okay.
Thank you.
Okay. So we are at the end of the inauguration of ICMSD 2020. So we heartily thank our chief guest, Dr. V. Balasubramaniam sir, guest of honor, Dr. Ezuta sir, for gracing this occasion. We also thank our beloved principal, Professor Dr. K. Parni Kumar. We thank other invitees, keynote speakers, session chairs, HODs, faculty members, participants, and all the students who have joined us. So we will sign off now for a short break of 5 minutes, and we will assemble again for the keynote session in the link given to us. Thank you. Thank you, everyone.
Prabhudas sir.
Yes, sir.
Yeah, you just continue, sir. Now itself.
Okay.
Sir is already there.
Okay. So we have the keynote
Okay.
speaker with us. So the session will continue. The keynote session will continue. Shanmugh Sundar sir.
Yeah, you can proceed, sir.
Yes, sir. So we will have the session with Dr. Ilango sir.
Ganesan Muthuswamy, sir.
Ganesan Muthuswamy sir.
Yeah,
Okay.
yeah. Sir is already waiting.
Okay.
Yeah, good morning, sir. Very good morning, sir.
Good morning. Good morning,
Good morning, sir.
everyone.
Yeah, Prabhudas sir, you can proceed.
Yes, sir. Yes, sir. Yes, sir. So we are happy to have Dr. Ganesan alias Muthuswamy sir. So for the keynote session, Department of Technology, UCSI University, Kuala Lumpur campus, Malaysia. A hearty welcome to you, sir.
Thank you for the invitation.
Okay. Sir has 15 years of teaching, management, research, and supervisory experience in Malaysian as well as Japan universities. Currently, he is an assistant professor with UCSI University, Malaysia. He has previously worked as a director at Open University, Malaysia. In addition, he has more than 15 years of industrial experience working for world-class organizations such as Bosch, Siemens, Motorola, and Panasonic in various capacities, ranging from an engineer to an engineering manager. He has received PhD degree in engineering from Osaka University, Japan in 2002. He has completed bachelor's with honors from University of Technology, Malaysia. He has published more than 60 research and technical papers in international and local journals, conference proceedings in the areas of production, operations management, total quality management, project and risk management, occupational safety and health management, sustainability and facilities management. So we are happy to have you, sir, and a warm welcome to you, sir. So
Thank you
please
very much.
proceed over the session, sir.
Thank you. Let me share the screen. Please allow me to.
Yes, sir. Yes, sir. Just a second.
Yeah. Okay.
So now you can share, sir.
Okay. Good morning to everyone. I'm really like to thank the organizers for inviting me to give this keynote lecture. And our previous guest of speakers already covered very much in the field of manufacturing, materials and mechanical. And my colleague, Professor Ulugu, also covered on a sustainable, what do you call it, development. And my topic is going to be not real materials or mechanical, but it's, yeah.
So you can continue.
Can I proceed?
Yeah, yes, sir. Yes, sir. I think.
Okay. So mine is more on how to manage whatever things that we are doing in the manufacturing mechanical materials. Because we want to sustain ourselves, we have to make sure that we are profitable and by achieving manufacturing excellence. So, but the famous method for achieving manufacturing excellence is by adopting quality management principles. So today my topic is the manufacturing excellence by adopting quality management principles. Okay, as all of us already knew, what is total quality management is an important factor for long-term success of an enterprise, especially in manufacturing industries, where quality is one of the most important success factors. Without quality, it is very difficult for us to sustain in the industry. This keynote talk attempts to present a list of TQM principles adopted by various enterprises for their operations excellence. These elements can be undertaken by any manufacturing organization striving for excellence. If you want to achieve excellence, then we have to adopt some form of a total quality management. Before we proceed, we must understand what is quality. Quality is not something that easily can be defined because it depends on the people who is defining it. And there's no single or universal definition of quality. And there are 5 ways we can define quality. Number 1 is conformance to specification. And we talk about materials, even manufacturing, we have a lot of specifications. So if a customer wants to accept our product, he has given certain specs. So it has to conform to the specification. So does the product or service meet targets and tolerances defined by the designers? Because it will be in the drawings. So that's a form of a quality definition. Another quality definition will be fitness for use. Evaluates the performance for intended use. For example, we compare a car, maybe Maruti and BMW. Both moves a person from A to a B destination. But the price will be different. But it fitness for use. It serves the purpose. So if we have a little money, then we go for Maruti, and we have a lot of money, we can go for BMW. Value for the price paid. We can evaluate the usefulness versus price paid. Just now, my example of BMW and Maruti, we can see that we can pay higher price for the same value of traveling. But in terms of comfort, the elegance, of course, the BMW will be different to us. Support and services also we can measure as a form of quality measurements, where quality of support after sales. Normally people will look after the sales of the service, whether we are getting the right service after we acquire the system or the item. And that will determine the quality of the product. And finally, psychological, the ambience, the prestige, the friendly staff, you know, when you go to the showroom of any car showroom, in the way they present themselves will give us some kind of a psychological influence in terms of quality of that particular product that we're going to acquire. We can compare the old ways of quality and new quality. The old quality, for example, like Rolls-Royce, Bentley, or personal banker, it's work of craftsmen. They're very specialized, you know, they're very specialized. The new quality is the work of a system, like Toyota, Apple, or Boeing aircraft. They adopt the new quality of a work of a system. The beauty of old is very expensive, is made for the few, use skilled hands, and is beautifully and functionally based, which is difficult to reach all the people. Whereas the new quality reduces cost, made for the many by the intelligent minds, and should drive the economy and make business more competitive. For example, our previous guests talk about producing materials which is cost effective, can be used by various industries. And this only can be done by the new quality, not by old quality. Old quality only cater for the few because it is custom and will be very expensive. We also can define quality for manufacturing, which is a theme of this conference, also for service quality, because service also is another form of production, because we have to deliver some services. Manufacturing quality focuses on tangible product services. For example, conformance, performance, reliability features. This is come under manufacturing. So you'll be measured against the conformance of the product, the performance of the product, the reliability of the product, as well as the features. So this is a form of quality in the manufacturing. Whereas in the service organizations, it is more intangible products that must be experienced. This is very qualitative in nature to judge the product. For example, quality is often defined by perceptual factors like courtesy. We go to a hotel or restaurant. So we are looking at a courtesy from the staff who's receiving us, the friendliness, the promptness, waiting time, and consistency. All those are actually intangible. It's difficult to measure. For example, you go to McDonald's, you need to have a consistency to get the same service every time you visit them. Or you go to Saravana Bhavan, you get the same consistency, because these are certain form of a process, a flow chart to maintain the consistency of their services. When we talk about quality, we must talk about the quality groups. There are a number of groups that promote quality. Stewart, he proposed statistical process control charts, which is an integral part of any manufacturing facilities. Dr. Deming, who proposed PDCA, as well 14 points for management. And I will cover about Dr. Deming later in the next slide, because he can be considered as a father of quality management. Dr. Juren, who proposed cost of quality, as well Crosby, he talked about quality is free. That means we don't need to pay any money to achieve quality. It's actually zero cost to achieve quality. As well, you promote zero defects. Finally, Ishikawa, who advocated a fishbone diagram as well. He assembled 7 quality control tools, which widely applied in the manufacturing industries. And finally, Dr. Taguchi, who advocated design of experiments. And there are experiments by his name, Taguchi methods. Dr. Deming, he lived in the previous century. He's actually the father of quality management. And he advocated quality chain reaction. Every action got reaction. And I will cover the next slide about this quality chain reaction. He also focused on SPC, or statistical process control, and other statistical tools to manage the production or manufacturing. And he also proposed 14 points for management for sustainability. As well, he advocated PDCA method, which is very important for continuous improvement. And the highest prize in Japan, the highest quality award, named after him, they call Deming Prize, because he was one of the persons instrumental developing Japan's quality system after the Second World War. And he's the one transformed the way the Japanese do things as compared to those days. Okay, this is a simple flow diagram of Deming's quality chain reaction. If you look at it, the ultimate aim of each enterprise is to achieve profits. This is the ultimate goal. Without profits, we won't be doing any business. And in any enterprise, we have an external as well, we have an internal. Internal is something that we can control. And external is sometimes, most of the time, is beyond our control. So in order for us to achieve profits, we have to ensure we must improve quality. Okay, when we improve quality, it means this arrow is upwards. directly it will improve productivity, because when your yield is achieving almost 99.99%, your productivity will be very high. And this will improve your manufacturing cost. When your manufacturing costs improve or reduce, you will have a profit from internally. That means you have less rejects, less scrap, less rework. Whereas when your quality is good, your product quality is good, you can satisfy the customer. The customer is extremely satisfied. Like Apple product, it's expensive, but the customer is very happy because of the quality. And when you have a happy customer, they tend to buy more of your product. And this will increase your market share. When your market share increase, you will have a increased profit. Okay. So at the same time, I also need to tell about this. When your quality is good, when your cost of manufacturing is less, you can keep your price lower. And this also will increase your market share. When your cost is very high to manufacture the particular product, you have to sell at a higher price. And this will reduce your market share. So it's a win-win situation. So when you have a better quality, you have a better productivity, you will have a reduced cost. At the same time, you can sell your product cheaper price. And it will increase the market share through quality as well, through the price. Eventually, you attain a good profits. How we can relate to a service organization? For example, let's take an academic institution. How we can adopt this philosophy? For example, internal is where the institution itself, where when the teaching quality, the teaching and learning quality is improved, it will improve the productivity of the academic staff. At the same time, it will reduce the cost. When the cost is reduced, you can keep your fees lower. When there's an increase in quality in teaching and learning, you'll satisfy the customer, who is eventually the students and the industry that you're serving. And that will improve your market share. In turn, then you'll improve your profits. So we can adopt this model not only for manufacturing, even for the service organization. Okay, let me cover about Deming's 14 points. Okay, number 1 point, it says, create constancy of purpose for improving products and services. That means whatever you do, there must be a purpose. There must be a cost-benefit analysis, whatever project we are doing. Not for promoting yourself or making famous. Make sure that you must have a return from what you are doing. That's the first philosophy. The second is adopt the new philosophy. That means we must do new things, adopt new technologies, new philosophies in the management as well in manufacturing. So all the manufacturing technologies transformed over the 100 or even 200 years. Now we are going to nano technology. Cease dependence on inspection to achieve quality. That means you don't depend on inspection to ensure quality. You must do it right the first time so that you don't have to re-inspect again and again for the same part. And this is very common when we don't have a trust or assurance in our manufacturing process. We tend to put a lot of inspection stations. We are afraid the defective product will reach the customer. And this is actually a redundant process, which will increase the cost of your manufacturing. So Deming says, cease your inspection, build quality in people as well in the process. And the practice of avoiding business on price alone. That means you don't avoid buy materials or machineries just price alone, because when you pay cheaper price for any material or machinery, you will not get the good quality unless you can work with the supplier. What he says, instead, minimize the cost by working with a single supplier. You should treat your supplier as a partner, not as a vendor. I worked for an American organization. We treat suppliers as our partners, not as a supplier, because without them, we won't be able to produce our product. So they will involve even in the proposal stage, because all our suppliers are registered vendors and they are our partners. And they need to survive so that we also can survive. So we must use win-win situation instead of win-lose. That means we should trust our suppliers as our partners. And this will ensure you can keep your costs low by working with a single supplier. Of course, you may ask me in a risk management contingency. Of course, you can have even 2 or 3 suppliers, but make sure you have evenly distributed the orders between these 3 suppliers and you work with them. Improve constantly and forever every process for planning, production, and service. That means continuous improvement, or in Japanese we call Kaizen. It is actually a way of life, because we expect at the end of the year to get a bonus as well as increment. Without improving your process, production, and service, how the organization able to give you an increment or a bonus? You must keep the costs low and lower so that the organization can give you a bonus, promotion as well, increment. So without improving your process, you don't expect the enterprise or in the industry to give you a salary increment or even a bonus. Institute training on the job. Training is very important. We always think if a person graduates from the university, that's it. Whatever you learn in the university may be outdated by the time you reach the industry. So you need to be continuously trained on the new philosophies, on the new technologies. Many organizations already adopted 40 hours mandatory training per year. And it is a supervisor's responsibility to ensure all the people under his or her responsibility to achieve these 40 hours training. And we don't send our employees for the sake of meeting these 40 hours. We must do a training need analysis. Make sure that we send them for the right training and make sure that there is an objective as well. There is some form of learning taking place. So you must evaluate the training as well. And then make sure that they bring back something from the training and implement in their job. So this is very important because this is called return on investment. Training, it is not just you take 1 or 2 days off and enjoy the lunch or tea and make some networking. You also have to bring back something for the organizations. Adopt and institute leadership. Without good leaders, not only the enterprise, even the country cannot move. So very important to have a good leadership to manage the company. Without a good leadership, we can't ensure good quality. Drive out fear. That means don't instill fear on employees. And it has become a very normal culture to put fear on employees. We have a lot of rules and regulations. We don't empower them. I worked for an organization with 5,000 employees. There's no attendance, not only for the managers, engineers, as well for the operators. No attendance because they trust the employees. When I asked my manager, how it could possible without attendance, that means without some kind of a punch card or even a barcode, how we can ensure we have 100% attendance of the productivity. He says, when we hire, make sure that we hire the right people. That means we don't hire paying lower salary. We hire them for the right skill, for the right knowledge, for the right price. And they have to go through few stages of interview. So we almost have filtered all the unwanted candidates. So 98 to 99% of the employees will be good. There'll be 1 or 2% escapees somehow came into the system. So during the 6-month or 12-month probation, we can evaluate them. But sometimes even the managers that 6-month to 12-month probation, and they'll show their true colors after the confirmation. So what we do is we isolate them, counsel them, retrain them. So why we should punish the 99% of the people because of this 1% bad apples? So by not having fear, the 99% people will give their fullest to the organization development. So this is the philosophy of one of the American firms that I worked for. And that 1%, if we still we cannot change them, we'll give them VSS, voluntary separation severance package or retrenchment package. So that will happen every year. The bottom 1% of the organization will be given a VSS. They have to leave the company so that the company can move forward. Break down barriers between staff areas. That means we shouldn't have a manager, engineer, operator, technicians. If you look at a Japanese philosophy, I work for a Japanese company, Panasonic. There's no room for anyone. Everybody sit in an open office concept. There's no even cubicles. Everything is no borders, nothing. We can see each other. And an American company that I work for, they don't have a blinds, or it is all glass partition rooms, and the door is always open. They call open door policy. That means you could walk into the manager's room anytime without making an appointment. So this is called break down the barriers between staff areas. Eliminate slogans, associations, and targets for the workforce. That means sometimes we see 0 defects, 100% quality. You know, all these slogans, sometimes it is just on the paper, not on the actions. So rather we believe in slogans, we get the action to the ground. So this is more important than we have a lot of slogans, banners, buntings, etc. Billboards. Eliminate numerical quotas for the workforce and numerical goals for management. Of course, we are talking about KPI, but the KPI is something that the staff is achievable. They call SMART objectives: specific, measurable, attainable, time-based, and then we must provide the resources for them to achieve the whatever target that we give. But a lot of time we give a lot of target to our employees, but we don't provide the conducive environment and resources for them to achieve this target. So although Deming says eliminate numerical quotas or target, but again, we can give them and make sure that we must provide them the right resources. Remove barriers that rob people of pride of workmanship and eliminate the annual rating or merit system. This sometimes we have a best employee of the month, best employee of the week. When you do this, actually we are telling that the other 99% of employees are not good for the particular week. So we shouldn't have this kind of a rating system and publicizing that the best employee of the month, best employee of the week, which is something that will derail the spirit of the teamwork. Institute a vigorous program of education and self-improvement for everyone. Encourage staff to acquire higher education while they are working. Provide them, encourage them to acquire certificate or some special skills, and you also can fund them. Many countries have special programs In Malaysia, we call HRDF, Human Resource Development Fund, where each enterprise must contribute 1% of the salary of the staff of that particular organization must park in a pool of fund where the organization can send their employees for training and acquire higher education using that fund. And this is one of the way in Malaysia we ensure the company encourage education and self-improvement for employees. Put everybody in the company to work and accomplishing the transformation. That means we shouldn't omit any layer in the company, that including the cleaners, the gardeners, the technicians, the operators, the tea ladies. Everyone must have the common understanding. They must feel that they're part of the company. It's just their job. They're actually contributing to the company. Without a cleaner, the employee don't have a peace of mind to work in the company, because whenever you visit the restroom, it comes out, you don't feel happy. Then it cannot contribute to the company. Or maybe contribute lesser to the company because its mind is not peace. So we have covered the 14 points of management, and these 14 points for management is widely adopted by many international and world-class organizations. Not exactly, but they have adopted most of it. We talk about world-class organizations like I worked before, Motorola, even Panasonic, even Bosch or Siemens, they have all of them. Okay, how we can compare quality in the US perspective versus the Japanese perspective? This is a true story of an American traveler. The US conforming to the requirements at the least cost. So they are actually based on specifications. As long as I meet the spec with the lowest cost, I achieve the quality. Whereas you look at the Japanese joint responsibility to make the end customer happy. That means when you make the end customer happy, then you achieve the quality. How we can make the end customer happy? Good quality, good customer service, reasonable price, value for money. Of course, we can buy a product very cheap from some country, maybe half of the price that coming from another country, but the product may not last longer, may have a safety issue, may have a sustainability issue, which is a long-term impact to the society. But most of the time, we only look at the short term. So when we assume that it is cheap, then as long as you meet a basic specification, then it's good. This is how the Japanese able to conquer the entire world by, with their good product. Okay, let me share a Matsushita story in the US, how they transformed the manufacturing in the US. In 1974, when Matsushita, now known as a Panasonic, because this is their brand name, so they have adapted the brand name, no longer it is called as a Matsushita, bought the Motorola Quasar TV plant in Chicago because the plant is not making money. Why? Why they are not making money? Because under Motorola, this was in the early 70s, every 100 completed television set, loading of convey lines needed an average of 140 adjustments or repairs to meet the quality standards. Why 140? Because of the manufacturing defects along the process. What happened? After 2 years under Panasonic or Matsushita, this figure dropped about 7 adjustments per 100 sets. So imagine who will make more money? Who will make the customer happy? Although they make 140 adjustments for the 100 TV sets, when it reaches the customer, we can anticipate more failures in the market, in the customer side. And there'll be a lot of warranty claims, which will bleed the company profits. Whereas with the Matsushita, it's only 7 adjustments per 100 sets. It means it is how many 100% reduction in the defects. And they're able to sustain this over a long period of time. So what change took place between Matsushita and Motorola at that time in the 70s? They only changed the top management. They didn't change the workforce. They didn't change the engineers. They didn't change the technicians. They even didn't change the suppliers. They changed the top management, the working culture of the top management, the attitude towards the work. This has brought tremendous improvement within 2 years, where they're able to reduce from 140 adjustment to merely 7 adjustments. This is a true story of Matsushita in the US in the 1970s. That's how they're able to conquer all the industries. Let me share another success story, and you'll be surprised. This is a Toyota story. As you know, Toyota, they are not originally automotive makers. They're actually an automatic loom design company. In 1921, they patented the innovative automatic loom design, where in 1929, the Platt brothers from England, they paid £100,000 for the patent rights for the automatic loom. So with this money, the father sent the son, who is Kichiro, to the big three automakers, Ford, Chrysler, and General Motors in Detroit for a year, how to make cars, like an intern. That means with that money, he want to venture into a new business. So he sent the son to Chicago, to Detroit for a year to study about the American automotive industry. So after his return, then they started the Toyota Motor Company, and he also came out with a just-in-time system, JIT, and implemented in the automobile production. And as you know, this idea of JIT, he discovered from the American supermarkets. Because during office hours, he will be in the plant. After office hours, he'll be visiting all the American supermarkets. And then you look at how do they replenish the perishable items like a vegetable and poultry, eggs, meat. And he got the idea. He don't believe in having inventory. Because you keep longer the inventory, you have a lot of wastages. Like fresh food, meat, vegetables, you can't stock up in the supermarket. It means as you sell, the new inventory will come in. So this is called just in time. And to your surprise, to our surprise, they started the company after learning from Americans. And in the 1970s, American top automotive executive from Ford, Chrysler, and GM traveled back to Toyota, Japan to study how to make better cars. Because by the 70s, they already conquered the American automotive industry, this Toyota. That means within 50 years or 40 over years, they're able to start a car company in Japan and then expand their wings to US and able to capture the market share in the US with the good quality, good customer service, and affordable price. And this is a success story of Toyota. Until today, Toyota is one of the most successful automakers in the world. Okay, so we are talking about all the philosophies that have been adopted in the early 1900s to up to 1980s. And then there's a new philosophies they call total quality management. As well, we talk about Six Sigma. So these are the two new philosophies came about in the 80s and in the 90s. So what is total quality management? There are 5 elements. Number 1 element is we must focus on customer. When we start focusing on profit, we start focusing on customer, we can't make profit. So first we must focus on customer, identify and meet their needs, what they want. If they want a reasonable, cheaper price, you must work with them to attain this. So stay tuned to the changing needs because the customer will change their likings. So you must change the product design according to the time and the taste of the customers. So this is the first philosophy. Second, continuous improvement. This is actually from the Dr. Deming. He says, continuous learning and problem solving. For example, Kaizen and Six Sigma is part of the continuous improvement methodologies. Plan, do, study, act, which was proposed by Dr. Deming, is very important to achieve your continuous improvement. Third, benchmarking. Adopt the best practices from the best-in-class companies. Don't reinvent the wheel. This is where the benchmarking becomes very handy. We don't reinvent the wheel. It is not copying, it's just adapting the best practices, which is freely available with the internet. You can adopt many new philosophies, many new methods for free. You don't have to pay any money. Fourth philosophy is employee empowerment. That means you empower all employees. You trust them as well external and internal customers. Very important to satisfy customers within internal organizations. Internally, we have internal customers. For example, we have many departments. For example, HR department supposed to serve the people in the company. The purchasing department supposed to serve the people in the company to buy goods, materials. And there's the internal customers. You must satisfy the internal customers so that the manufacturing or the whatever department making product, they're able to satisfy the external customers who paying our salary or our income. So without satisfying the internal customers, it's very difficult for the people in the company to satisfy the external employees. We always think we are one company, we don't have to satisfy internally. There's a lot of politics will go on within the company. They call backstabbing or, politics, office politics, which is not good because when you have this problem, how this organization able to satisfy the external customer in terms of the cost, scope, and the time to deliver the product on time. The triple constraints in project management, cost, scope, and time. It's very important to achieve internal customer satisfaction so that we can satisfy the external customers who actually giving us the money by buying our product, supporting our product. The second is team approach. You must work in teams around processes, small group activities. A team should not consist more than 10 people. When you have more than 10 people, we'll have a sleeping partner, non-productive team member. So the ideal is around 8 to 10 people. The 10 people is the most. So every process must have a small group activities in the form of team. In Japanese companies, very famous doing this. Okay, they call quality control circles. They have a lot of circles within the processes where all the employees, including the technician engineers within that particular process, will have a team and they will continuously improve the process. Meet weekly to analyze and solve problems. So meeting is very important. And the meeting should be discussing objectively the problem that you're facing, what are the action items, what are the support required from the top management, and how to solve. And this should be done weekly basis. Like in the project environment, they'll be meeting almost daily because the project environment is slightly different than manufacturing. Finally, use of quality tools. We must make decisions based on data analysis using modern tools. That means there's no intuition-based decision making because you can make mistakes. So data is very important. Data analysis, now we call it big data. So we must make use of all the data, employ the right tools, 7 quality tools, DOEs, SPC, whatever softwares. Use that analysis to make decisions. Transforming an organizations from olden ways to new way, okay, from motivating through fear and loyalty, we must motivating through shared vision of the company. So every company must have a vision and mission. And everybody must have a common understanding. They must be in the common platform. We shouldn't have aliens in the company. They do understand the company philosophy. Second, attitude is very important. Like, it's their problem. That is the old ways of doing things. But now, ownership for every problem affecting the customer. We must have a people taking responsibility. The process owners for the particular process must own the problem. Then work within the team to solve this problem. Accountability is very important. Another attitude, the way we have always done it, that means we always do use of all methods. We must adopt the continuous improvement. Look for the new philosophies, new technology, new processes, where the benchmarking can help, which is part of TQM philosophy. Decision based on assumptions, judgment calls, these are always intuition. Now we make decision based on data and facts. Everything begins and ends with management. This is the old way. The management tell you something, and then they'll tell whether we accept or not your outcome. That's very wrong. Everything begin and end with customers. What customer want, we deliver, then we see whether they're happy or not. And that will determine our survival. Crisis management required, this is always firefighting. That's the old way of doing things. Now we do it right the first time. The JIT, do it right the first time. Choosing participative or scientific management means we choose either one, either participative or scientific management. But in the new way, under TQM, we choose scientific as well participative, like a qualitative and quantitative together. So we have to adopt some form of scientific as well a team input, the participating management. So scientific, we use the data and then we make judgment. We go for the majority opinions based on the data. And then we make judgments. Okay, the second new philosophy is Six Sigma. When you talk about Six Sigma, Motorola will be there because they invented in the mid-80s. Okay, then you know that all this yellow belt, white belt, green belt, and black belt. Okay. These are the things that to promote the Six Sigma, which was advocated by General Electric, by Jack Welch. The term Sigma is often used as a scale for levels of goodness or quality. So Sigma is in the statistics. So this scale, Six Sigma is equal to 3.4 defects per million opportunities. We call DPMO. That means you make 1 million product or services, you can expect the most 3.4 defects. Then you are Six Sigma quality, which is very, very good. Okay, let us see how we can translate into numbers. Okay, So therefore, Six Sigma started as a defect reduction effort in manufacturing and was then applied to other businesses as well processes for the same purpose, including the service industry. Okay, we look at these numbers in the scale, okay? Normally, any organizations, when they start new, there'll be somewhere 1 to 2 sigma, which is about 70%, up to 70% good, and rest about 30% will be bad or defects, because you have to make some money, you know. So, and then you should elevate yourself to 3 sigma, which is about 93.3%, which is considered good for some industries. Then 4 sigma, which is 99.38, and then 5 sigma, which is 99.977, and then 6 sigma, which is 99.9997%, equivalent to 3.4 defects per million opportunities. Okay, you may ask me, sir, what's wrong with the 99% quality? Let us compare. 99% good is a 3.8 sigma, whereas 6 sigma is 99.99966% good. If we are 3.8 sigma, there are 20,000 articles of mail lost per hour. Whereas if you are 6 sigma, only 7 articles, okay, lost, okay, per hour. So 20,000 to 7. Unsafe drinking water for almost 15 minutes each day if you are a 3.8 sigma. But if you are a 6 sigma, unsafe drinking water for 1 minute every 7 months. Way apart. Okay. 5,000 incorrect surgical operations per week. When you go to hospital, you go for surgery. If you are a 3.8 sigma, there are 5,000 incorrect surgical, you know, average around the world per week. But if you are a 6 sigma, only 1.7 incorrect surgical operations per week. There are 964 US flight cancellation per day under 3.8 sigma, which is 99%. Whereas 1 US flight cancel every 3 weeks, which is come under 6 sigma. 20,000 wrong drug prescriptions dispensed each year. When you go to a pharmacy, when you buy a medicine, if you have a 3.8 sigma process, you have a 200,000 wrong drug prescribed. Whereas we are a 6 sigma, 68 wrong drug prescription dispensed each year. So you can see that what the difference between 99.996 compared to 99%. Okay. And you may ask me, is there any organizations already achieved 6 sigma or beyond? Yes, there's one organization in the country that this conference is hosted. Okay, let me share the company name. It's a 6 sigma organization. There's no known or documented organization that has reached beyond 6 sigma level of quality anywhere in the world except the Mumbai Dabbawalas. I'm very sure you have heard of this Mumbai Dabbawala. It is actually a tiffin carrier company in Mumbai. Okay, and they have attained 1 defect in 16 million transactions, which is about 6.7 sigma, if you calculate. And you'll be surprised to see their setup. Okay, let me share. And this is an example, how do they carry the tiffin? Okay, the tiffin basket weighs about 75 to 80 kg. Okay, for them, work is worship. Okay, in Tamil we call Seyyum Tolile Devam. Okay, so they believe in work is worship. The history of Dabbawala started in the 1890s, about 130 years organization. It's a charitable trust registered in 1956. Average literacy rate, 8th grade schooling. They cover 60 to 70 kilometers area, distance. The strength of this Mumbai Dabbawala is about 5,000. Number of tiffins they carry is about 2 lakh tiffin boxes one way. They also collect back the empty tiffin, which is about 4,000 transactions, not including transit. Transit means probably is more than 4 lakh transactions, okay? So in terms of from the end to end, it's about 400,000 transactions. Time taken one way is about 3 hours. So they in fact achieve more than 6 Sigma consistently till today, okay? So before I end this presentation, let me share the video about, I think about 4 minutes of this Mumbai Dabbawala. Then we'll go for the question and answer sessions.
If you visit Mumbai, you are bound to notice the Dabbawalas. You may not realize this, but the Dabbawalas are a very important part of life in Mumbai. They are the ones who make sure that nearly 200,000 people get their lunch in time at their offices or schools every day from home. Their operations are so efficient that world personalities like Prince Charles and Richard Branson have visited them. They have been invited for lectures at business schools. They are even said to be Six Sigma compliant. Now, what is a dabba? A dabba is simply a tiffin box carrying home-cooked food, which is to be delivered from the home to a person in an office or a school. And the dabbawala is a person who picks up the food from the home and ensures that it is delivered to the right office to the right person on time.
नमस्कार, मेरा नाम रघुनाथ धोंडेवा मेदगे हूँ। मैं डब्बावाला एसोसिएशन का प्रेसिडेंट हूँ। हमारे डब्बा का सर्विस 18 से 90 से शुरू है। हमारे टोटल 5,000 मेंबर्स मुंबई में कार्यरत है।
It all may sound fairly simple, but imagine doing this in one of the most densely populated cities in the world. The dabbawalas have high rates of accuracy and their error rates are shockingly 1 in a million only. And what is even more impressive, that all the dabbawalas are fairly illiterate and have no use of any technology. The only motorized transport used is the Mumbai local trains. Other than that, they make use of hand-drawn carts and bicycles.
मेरी ग्रुप की साइकिल है, अंधेरी स्टेशन में मैं छोड़ के जाता हूँ, तो मैं दूसरे ग्रुप की साइकिल डिलीवरी के पॉइंट पे यूज करता हूँ और मेरी साइकिल वो लोग यूज करते हैं.
The dabbas or the lunch boxes have a color coding scheme which makes sure that they get to the right destination. The structure of this organization is fairly flat. It has just 3 levels. First, the governing body. Second, the team leads or the supervisors. And third, the dabbawalas. And everyone is an equal shareholder in this organization. There are no bosses and the earnings are equally divided.
हर एक बंदा का काम टीम के लिए करना है. अगर एक बंदा कम काम करेगा तो पूरी टीम की इनकम सोर्स लो हो जाती है.
All the dabbawalas come from the same Varkari sect, and whenever any replacement is required, villages that have this Varkari sect are approached for suitable candidates. To join this organization as a dabbawala, the dabbawalas have to bring a few things: a long wooden crate, 2 bicycles, and ₹20 for a Gandhi cap that they wear. And how much do you think would it cost to avail of this very efficient dabba service? Less than $10 a month. While the operations are fairly simple, the dabbawalas are now beginning to work with newer technologies. You can SMS them or you can also log on to their site mydabbawala.com to avail of their services.
अभी लंदन में भी प्रिंस चार्ल्स की शादी में जाकर आया हूँ. इटली में 2 बार जाने का मौका हमें मिला है. बहुत मैगजीन ने भी हमारी रिसर्च की थी, बीबीसी ने भी डॉक्यूमेंट्री वहाँ बना के दी थी. हमारे ऊपर देखते हैं कि इनको क्यों ना 6 सिग्मा देना चाहिए. हमें तो पता ही नहीं 6 सिग्मा क्या है.
And given their reach in Mumbai, Microsoft has also partnered with the dabbawalas. The dabbawalas distributed leaflets and wore Microsoft branded clothes to spread awareness of genuine Windows softwares to their customers.
5,000 बम्बई के डब्बे वाले 4 लाख टिफिन का ट्रांजैक्शन पर डे लोकल ट्रेन से, साइकिल से और मैन पावर की वजह से कर रहे हैं.
I'm Premjit Singh, showing you Mumbai.
Okay, so we have end the video. Let me end this slide, and then we will go for a question and answer. Okay, so let me end this presentation by summarizing what we have I've said. In order for us to achieve manufacturing excellence, we must adopt total quality management philosophies. And it is a well-proven companies like General Electric, Motorola, Apple, even Panasonic, Bosch, they have all adopted total quality management philosophies. And they have already proven in their operation excellence. In fact, General Electric and Motorola saved more than 10 billion US dollars by implementing Six Sigma in their processes. And from the video, you can see that they don't use any technology. They use simple process. And when you talk about sustainability, they don't use any electric vehicle except the Mumbai local. The rest is they use everything is manual and walking and bicycle, and which is very sustainable. And they can able to achieve beyond 60 without even using any apps. All the courier companies now, they're using all these modern tools. We have a delayed part arriving our home, a wrong product arriving at our home, a damaged product arriving at our home. And Mumbai Dabbawala never failed to deliver their tiffin box on time. And they always say, the train can be late in Mumbai, but not the Dabbawalas. Even with the extreme weather conditions like a flood, flash floods, the lunch will reach on time. So this is their philosophy. The philosophy is customer is their king, work is worship. Okay, so let me open this session for question answer.
Thank you, sir. It was very nice listening you, and it was really an informative session, sir. Thank you for your presentation. And it is the time now for the participants. Participants, if you have any queries, kindly come online and please do interact with the speaker, please.
Yeah. Thank you, Ganeshan sir. Thank you. Thank you very much, sir. Thank you, doctor. Thank you, sir. Now, screen is visible. The screen is visible.
Okay, okay, please visible.
Yeah. Prabhudas sir.
Yes, sir. We can close. So thank you, sir. Ganeshan, sir, we kindly request you to display your contact details. So it will be useful for our participants for any further queries in future, or even you can put it in the chat box, sir, please.
Okay, definitely.
Thank you, participants. I welcome you for the next section. Our eminent personality, IA Parnichan, is also joined with us. Prabhudas sir.
Hi, sir. So we heartily thank Dr. Ganesan, sir,
Good morning, sir. Good morning.
for presenting the first keynote session. Thank you. Thank you, sir. And we heartily welcome Dr. I.A. Parni, sir, who's going to address the next session. So before moving on to the session, I take the privilege of introducing Dr. I.A. Parni, sir, Associate Professor Mechanical Engineering. He's working as Associated Professor in the discipline of Mechanical Engineering, IIT Indore. After completing his doctorate from IIT Madras, he worked as a postdoctoral research scientist in Graduate School of Information Science and Electrical Engineering, Kyushu University, Japan. He has developed mechatronics and instrumentation lab at IIT Indore. His area of expertise includes laser-assisted surface processing, micro machining, smart materials, and shape memory alloys. He has published more than 100 international journal publications, and he has filed 6 Indian patents. He has executed projects from different funding agencies such as DST, SERD, DAD, JSPS, DRDO, MHRD, worth rupees 600 crores. He has closely worked with industries such as Volvo Asia, John Deere, WAPCO as technical consultant. He has strong research collaboration with University of IFW, Dresden, Germany, Kyushu University, Japan, and Jeju University, South Korea, St. Petersburg State University, Russia, and Purdue University, US. Sir is a life member in Indian Laser Association, RRCAT Indore, and Smart Materials and Structures, IIC Bangalore. He has received Alumni Award for year 2015 under Research and Innovation. He is a recipient of Kyushu University Friendship Scholarship and ACT National Doctoral Fellowship. He is a member of SPIE, Indian Laser Association, Institute of Smart Materials and Structures. He was a founding head of Metallurgy Engineering and Material Science at IIT Indore, followed by heading the Mechanical Engineering discipline at IIT Indore. Currently, he is the Dean Research and Development at IIT Indore. We are happy and privileged to have you, sir. Pani, sir, we kindly look forward for your session. Please, sir.
Thank you very much for giving me this opportunity. So this is a very good forum. So in this forum, I would like to discuss some of my key research areas which we are doing in our laboratory, relevant to some of the industries, which I would like to share over here. So the topic which I am going to discuss today is something related to laser and smart material, the key elements in advanced manufacturing. So as far as this laser is concerned, so we all know that these lasers are highly flexible and it has a capability to cater the different advanced manufacturing concepts. So as a manufacturing engineer, so we all are moving towards the concept called Industry 4.0. Since we have an abundant amount of internet source with us, so we are trying to work or utilize these internet for an appropriate communication, as well as to make a plant completely automation. In fact, I can just give you I can give you a simple example that in which recently you might have heard that one of the car companies which was dealing with which deals with some of the automotive systems during the pandemic situation. So they would be able to, they have promised to come up with ventilators, etc. So this is because of the flexibility in their production line, which is being taken care by using this Industry 4.0 systems. So as far as this is the overall view of an Industry 4.0 layer. So in this Industry 4.0 layer, additive manufacturing is going to play a major role. So as far as additive manufacturing is concerned, so just to give you an overview, you all know that. So nowadays, in many cases, shop floors are getting shrink, so that you have a flexibility to go ahead with a customized product. Like one example, I can just say the replacement of hip and knee joint. So earlier, hip and knee joint replacement was very difficult because getting a customized structures has its own integrities. Whereas with respect to the recent advancement in such kind of 3D printing or additive manufacture, so we could able to reach a point where we could make easily make a customized structures based on the different human body features. Okay, so similar to this, there is one more area which I would like to talk, which is called as smart materials. These smart materials have a potential application in towards actuators as well as sensors. So as far as the smart material is concerned, so this is just to give you an overview about how a laser is flexible. So these lasers has a capability in such a way that, for example, if you want to manufacture any kind of complex product, so those complex products can be easily manufactured, and all the post processing can be done at the same level. So now when we come back to smart materials. So as far as smart material is concerned, so these smart materials have a potential application in such a way that it has a capability to biomimic. Like for example, if I want to have, or if I want to simulate my hand movement, hand and my limb movement. So basically we will be integrating lots of motors under it to simulate a hand and a limb movement. but as an alternative approach. So what you can think of is there are some materials which has a capability in such a way that when you try to supply a heat, it can mimic your hand movement, so that it has its own advantage towards advanced manufacturing system. So one such smart material I'm just showing over here. So this is a smart material which we call it as shape memory alloys. So these shape memory alloys basically, so this is a spring. So I'm just trying a weight to it. So when I try to apply a weight to it, obviously there is going to be a deformation. When I try to give an electrical biasing, it tries to comes back. Okay. Similarly, on the other hand, if you have spring and you are just deforming the spring and put it up in a hot water, so it comes back to its original shape because of the heat which is being supplied to it. If I try to look into the overall mechanism behind it, so the overall mechanism is basically initially the spring are in the martensite phase, then you are deforming it. This is called as a deformed martensite. Now I'm just putting it in a hot water where you can see it is automatically taking up the shape. So this is called as an austenite phase where you are supplying a heat to it, and finally when it is completely getting immersed, it comes back to the martensite phase. So this is, you can see how responsive it is. At an instantaneous time, it can come back to its shape. Okay, so these are quite interesting materials which has its own application towards sensors or actuators in an advanced manufacturing scenario. So basically, to give you an overview, so these materials are called as programmable materials. So the main advantage of these materials is these materials can be programmed to any shape and it can be recovered to any shape. So these are some of the training methods which are being employed to program these materials and to achieve a shape. So as far as these shape memory effects is concerned, there are wide variety of shape memory alloy materials which are available for us. So among this, nickel titanium and copper based shape memory alloys are widely used for commercial applications or for experimentation. So this nickel titanium based shape memory alloys, basically it works in the window of something around 80 to 130 degrees Celsius, and these copper-based shape memory alloys works in a domain of something around 250 degrees Celsius also. So basically, both these windows are being employed in an industry environment so that you can use it or you can pick it up for your own applications. So now in this talk, we will be discussing about how a laser and a shape memory alloys are being used for different levels of advanced manufacturing. In fact, I would say these are some of the case studies which we have done in our laboratory for different industry levels, capturing these advanced manufacturing systems. So if I try to look into the challenges of shape memory alloys, these are the wide varieties of challenges which are being involved with respect to shape memory alloys concerned. One is with respect to a tedious training. Another one is we are more, it's an interesting fact that if I try to change my composition, how does it behave? So that is almost a kind of $1 million question where people are looking into it and people are also probing into it to see its structural behavior. Almost 10-15 years, people are being working in this particular line to get an overview about the variation in the composition of the shape memory alloy structure. Third important concept is something related to the thermomechanical behavior. So this thermomechanical behavior is nothing but, so any material you take, failure is going to happen. So obviously if failure happens, so we are there to study the failure and to give an overall picture how the failure is happening, how to overcome this failure, so that this will give you an idea to investigate how you can use the material further along. For shape memory alloys also, so there are some mechanisms which are available to study the thermomechanical behavior. So we have also attempted some kind of thermomechanical behavior analysis, which I will be explaining. And then most important thing is, so in the case of shape memory alloy is concerned, so commercially you get the shape memory alloy in the form of wires or in the form of sheets or in the form of springs. So as an alternative approach, what we thought is, since we have a laser in hand, why can't we use a laser-based additive to manufacture these customized shape memory alloy structures for different aspects? So our first case study is that. So our first case study is we want to use the shape memory alloy as a tool for Industry 4.0 or smart manufacturing. So for that, we have built a customized shape memory alloy structures. So using a laser additive manufacturing. Okay. So the motivation behind my work is this. So this is an industry 4.0 environment. Basically, this is a pretty old machine which is available in one of the company, which was started in the year 1970s. With an advent of recent advancement, so obviously these the company is not ready to shred out the machine. So instead of that, so we thought, why can't we modernize that machine? So since it is of 1970s, so we need to integrate some kind of sensors in it, so that when we try to integrate sensors in it, it becomes intelligent. So when it becomes intelligent, it start communicating to the manager app. So basically, it is something like we are trying to mimic the complete machine in a digital platform, which we call it as cyber twin. So this cyber twin is nothing but whatever performance the machine gives. So the entire performance is being studied using the cyber twin system, so that the cyber twin will try to almost check the performance. We can get the data of the performance at each and every level. And most important thing, the concerned manager can observe what are all the detrimental effects which are happening during running the machine. Like for example, I would say, like when your machine is going to fail, you can easily identify it. So this is one such arrangement. What we have made over here is, so in this one such arrangements, what we have made is, like we have a spindle. So we have the spindle is connected to a column. So like for example, anytime when the you consider let us consider this as a drilling machine. So this drilling machine, before it fails, obviously first the tool will wear out. Once the tool wear out, then obviously there is going to be a vibration or a chatter which is going to get developed. And because of the vibration, a huge amount of heat will get liberated in this particular region. When the huge amount of heat is liberated at this particular region, so obviously the next step is the failure. So since I have a material with me which can respond to heat, and not only it responds to heat, it can be also used for arresting the vibration, or it gets actuated with respect to heat. So what we have done is we have made a spindle kind of arrangement. So in this we have kept the shape memory alloy deposited tool holder. Okay, so it is, which is in the form of a ring, and this is the focusing optics, basically, which is mainly meant for capturing the data. And what we have done is, so that whenever there is a vibration is there in the spindle, so there is going to be a certain amount of heat which will get liberated. When these heats get liberated, there is going to be an expansion. This expansion is going to get arrested by the shape memory alloy rings. So this is what the idea, so that this becomes an intelligent tool holder. And one more thing is here, since I'm using an infrared camera over here, the infrared camera will pick up the signal from these shape memory alloy deposited tool holders. And whenever there is an actuation is happening in the shape memory alloy tool holders, immediately a signal is fed to the manager, so that the change in the production line can be appropriately decided by the manager. So this is what an idea, what we thought of. So basically, as far as things is concerned, so the major challenge in front of me is I need to make such kind of shape memory alloy based structures. So for that, I'm opting a system which is a laser additive manufacturing. So this is called as a fused deposition system. So as this fused deposition system is available in our next door. So there is a Center for Advanced Studies, which is called as RRCAT. It's a part of Department of Atomic Energy. In fact, this machine was built by them. So in this machine, so what they have made is, so this is a nozzle, so which we call it as coaxial feeder nozzle. So in this coaxial feeder nozzle, let us consider I am considering nickel titanium powder. Nickel, I am feeding it through this path, and titanium, I am feeding it through this path. And here I am just using a focusing optics where the powder is fed to it. The powder are fused because of the focal point which is being generated over here. When the focal point gets heated up, then what you can do is you can just manipulate this to get the structure. In fact, this is the complete system what we have used. And this is the coaxial feeder what we have kept. And through these coaxial feeders, the NATA powders are being filled. And most important thing is, so this is your glove box kind of arrangement. So in this glove box, basically what we have made is we have filled the argon into it, and we have used a 2 kilowatt fiber laser system to fed into it. So this 2 kilowatt fiber laser system is well focused in such a way that it will try to fuse the material. And when you try to manipulate the material, you can build the structure. So this is what an idea, because we have completely fitted the system in a CNC stage. So when you try to fit it in a CNC stage, so that it is easy for you to build any kind of structure. So this is what the structure we have built. So basically we took a small titanium plate, So over this titanium plate, we have deposited the shape memory alloy structure, which is in the form of a ring. We have cut this ring using a wire radium so that this ring can be easily fitted into the collet which I have shown. But here, the major challenge which I am facing is because I am starting from scratch. So it is something like it is a challenges job that I am just creating a customized structure out of it. So in these customized structure, so what I'm doing is, so I have a titanium substrate. So the major parameters which basically affects my structures are the wettability. Okay. So in order to have a control over the wettability, I need to have a control over the laser energy and the aspect ratio which I am trying to employ. So what I have done is, so we have just changed the different parameters and we have went for a different aspect ratio geometries, and these aspect ratio geometries were well connected. Then we did a complete scanning electron microscopic analysis. In fact, which one thing which I mentioned earlier, that changing the composition is one of the key area. So what we made is we went for a different composition. One is with Ni50 and titanium 50, Ni45, titanium 55, Ni50, titanium 50, Ni50 and titanium 45. So we went for a different combination and we went for fabricating these structures in an optimized way, and we went for a detailed characterization systems. So some of the characterization includes scanning electron microscope analysis. So in this scanning electron microscope analysis, we have done the structures, and then we have also studied the mechanical properties in detail. So as far as mechanical property is concerned, so we were more concerned about the ductility and about the hardness which is going to get impart on the surface. And the most important parameter is I would like to look into the shape memory alloy property, because the shape memory alloy property, unless and until if you don't have the shape memory alloy property, it is not going to sense, neither it is going to sense nor it is going to actuate. So in order to ensure the shape memory properties, so basically the shape memory property is basically ensured using these beta phases. So with these beta phases, so it is easy for me to ensure the shape memory alloy property. So with these which is available over here. So this availability has been checked with respect to a XRT analysis, which gave me a clarity about the grain size through which we could estimate the grain size, and we compared it with the AFM. This is one important characteristic which is called as DSC, which we call it as differential scanning calorimetric analysis. So this differential scanning calorimetric analysis basically gives me a picture about the phase transformation, because if you look into the major physics behind this, there is an austenite phase and there is a martensite phase which is available in the picture. So as far as austenite phase and martensite phase is going to cater my actuation property, which is well taken care, which can be characterized using a differential scanning calorimetric analysis. So for that, what we had is, so we went for two different kind of arrangement. So that is one, we took a commercially available system. From the commercially available system, we took the DSA and XRT analysis, and almost we compared that commercially available system with the as fabricated system, and we observed that almost a similar fashions were observed. So the next level stage is, in fact, we want to impart or improve the property of it. So for that, what we did is, so we went for some kind of concept called laser shock peening and laser annealing, because in the case of additive manufacturing is concerned, so here I had a metal powder. So I'm just melting that metal powder and I'm manipulating it. So when I melted my metal powder and when I manipulated, obviously there is going to be certain amount of defect which will get involved in. So some of the major defect which we observed is there was a random crystallization. That was one thing. In the meantime, there was a random stress which was getting induced. So as far as this random crystallization is concerned, in order to make a uniform crystallization, so what we made is we just scanned our laser through the surface. So when we scan the laser through the surface, so then obviously you can have a control over the crystallized structure. Another one, what we did is, so we went for a concept called laser shock peening. So this laser shock peening is quite an interesting technique, where when you try to bombard with laser, so obviously you get in a certain amount of fragmented kind of layer, and so these fragmented layer will try to improve the uniform stress strain behavior in the property. So this is what we tried over here, and we also tried to incorporate, or I would say that we earlier we were working with nickel titanium, basically a binary alloy. Then we were moving into the ternary alloy, where we just introduced a copper and we were trying to look into overall behavior of the system. So this is a laser sharpening arrangement what we made. So in this laser sharpening arrangement is concerned. So here you have a sample. The sample is being immersed in an underwater condition. So over an underwater condition, so you are just trying to put a sacrificial layer on it. So these, whenever a laser is made to interact on the surface of the sacrificial layer, so there is going to be a certain amount of plasma which will get expelled from the surface, and these plasmas are being pushed towards the sample, finally ending up in a proper beam. And this is one of the laser annealing concept which we have imported on the sample, which is a kind of a post-processing which we have employed in it. So this is a ternary alloy based system which we have done. So in this ternary alloy based system, so basically we what we have done is we have incorporated copper in the structure. So in this copper, so by incorporating the copper, so we can somehow tune the mechanical property of the system. So what we made is basically, so we just mix TA and Cu. We almost we ball milled TA and Cu, and we fed it through the nozzle. And through the nozzle, we made such kind of brick kind of structures. Basically, these kind of brick kind of structures were intelligent structures used for milling operation. And we also did a complete detailed characterization, including scanning electron microscopy and a DMA analysis, basically in order to study the storage modulus capability in detail. And with respect to the storage modulus capability, we could able to study the austenite phase and the martensite phase, and the mechanical correlation with respect to the austenite phase and the martensite phase in behavior. And most interesting thing is, this was highly helpful for us to map with our system and directly use it in the production field. Okay. So the next case study which I would like to discuss about is called as laser forming, which is a kind of a die-less manufacture. So formability, we all know that if I want to form any kind of sheets, basically you require a punch and a die. So a punch and a die. So, but basically the cost of the die is sometimes quite heavy. Okay. So in fact, this case study, which we have done it using in collaboration with one of the company, where they were involved in manufacturing some kind of brake pedals and clutch pedal based prototypes. So what we did is, these brake pedals and clutch pedals, they were manufacturing it for a different industry. So for that, first they need to make a prototype. So in order to make a prototype, obviously they need to make a die. So if they need to make a die, even for variation in angles, so they need to change the die. So the die cost was quite heavy. Almost, you know, that a cost of a die is something around 1 lakh or so. So that's how the problem came into our mind. So we thought of going for a laser forming. In fact, the laser forming has an advantage where you don't require a die. You are just trying to use heat over the surface. So this is a very good example how a laser forming is being employed. So for example, I have a sheet metal where I need to have a bending something like this. So this is my sheet metal, and the laser is made to irradiate on the surface. When the laser is made to irradiate on the surface, there is going to be an expansion and the contraction. So like any metal, if you take, so when you try to heat it, obviously there is going to be an expansion. When you cut off the heat, there is going to be a contraction. Here I am using a laser. So when I'm using a laser, obviously it's a kind of a localized heating. So when a localized heating is employed, so obviously there will be a kind of expansion at the localized heating and a contraction at the localized heating. So at the contraction after the cutoff of the heat. So when you try to apply a constraint to it, by appropriately applying a constraint, so you can have a bending, and this bending will be employed over here. So this is an overall arrangement. So with laser forming, you can employ you can go for different operations like upsetting, forming, bulging, etc. So in fact, these are the different operations which can be formed with laser forming. In fact, it is well correlated with the mechanical analogy, where you can do a bending, you can do an upsetting, and you can do a buckling mechanism over here. Okay, so this is the mechanism of bending, so which I have explained earlier, where you are trying to impart the heat. So when you try to impart the heat, there is going to be an expansion and contraction. So with respect to an expansion and contraction, so there is going to be a bending which will be taken care. In fact, there is a video on laser forming which I will be showing up in the last after the presentation. Okay. So the idea for our work is basically for our case study is, so we want to go for a die-less manufacturing. So the parameters involved in these such kind of laser forming is basically your scan speed, your overlapping region, which is well deployed over here, and your thickness of the material what you are using, and basically the energy how much you are imparting on the surface. So this is what we are trying to work upon. So the idea is we want to make such kind of brake pedals and clutch pedals, basically a prototype version using these laser forming technique. So the idea which the company gives is basically they want to incorporate a flexible level in such a way that the operator, once he feeds the thickness of the material, the type of the material, and once he feeds the thickness of the material and the type of the material and the bending angle, automatically the different laser parameter has to come out. So for that, first we have to do a huge amount of trials. So that is what we did. So what we did is we went for a very different material with different thickness. So the thickness of the material was ranging from 3 mm, 5 mm, 8 mm, and even we went for a 10 mm. So we used a carbon dioxide laser, which has an energy of 1.5 kilowatt to 3 kilowatt. So we varied our passes from 0 to 210, and we had a scan speed of something around 0.6 to 1.2 meter per minute, and a laser spot diameter of around 9 mm to 30 mm in the region. So we went for a complete wide sweep. So I should say, in fact, we did the results in such a way that we went for a variation in a thickness, something around 3 mm, 5 mm thickness sheets. And these 3 mm, 5 mm thickness sheets were well correlated. And we changed the spot dia as well as the bend angle. And that is, we scanned our power. So when we try to scan our power, so we could see a complete wide spectrum of bend angle as well as the scan beam as well as the bend angle, which we took it as an input and we went along the detail analysis. So in fact, this is one sample which we have done with a 1 centimeter thickness sample. So in this 1 centimeter thickness sample, so we are just passing it through a laser. So when we try to pass through a laser, you have an unaffected zone, you have irradiated region, and this is your heat affected zone. So when you try to scan through a laser, so obviously there is going to be a bending, and the major aspect, or I would say a major defect over here is earlier we thought of employing this for directly for the actual condition of brake pedal and clutch pedal. But the major issue what we observed is because of the heat affected zone, when we try to go for a cyclic loading, there was a huge amount of failure was observed. So that is the reason we didn't want to go in that particular direction. So we almost restricted our application towards the prototype based system. Okay, so with respect to a prototype based system, so since we are going for a detailed analysis, we went for a scanning electron microscopy. So basically, this is an unaffected region, this is an irradiated region, and this is an unaffected region, and this is an irradiated region at the top. So, and we also went for a complete mechanical testing. So as far as mechanical testing is concerned, so we went for a tensile testing where we made tensile testing samples at different points, and then we went for a complete mechanical analysis. So with respect to the mechanical analysis, we could almost segregate how much is the mechanical property is getting improved. So this is the laser formed samples which we have done for the industry. Now we have extended this work for shape memory alloys, because the shape memory alloys, we have seen that when you try to deform it, so obviously, so there is a chance that when you try to apply heat, it comes back. So a similar thing can happen when you get a sheet, because the shape memory alloy is made out of nickel titanium. It has a potential application towards aerofoil structures, because in the case of aerofoil structures, like you have your engine fan, if it is intelligent enough, so that you can just tune your drag and the lift force. So when you try to tune your drag and the lift force, then it is easy for you to manipulate your inlet as well as your outlet. So what we made is, so this is one of the collaborative projects with GE India, where they were involved in laser forming of these sheets. So these sheets were we tried to bend with a die where there was some issues were observed. So what we made is, so we went for a laser forming, and we want to make some kind of corrugated aerofoil structure, so which is slightly complex. So this corrugated aerofoil structure, we attempted with the laser forming with a thin sheet of foil. In fact, we changed the fixture in such a way that we could get the aerofoil. In fact, this is the aerofoil structure, so which we have made with a flange kind of arrangement. And interesting part in this is it didn't come back basically. So there was a minor deviation which was achieved, but apart from that, almost it had its own. It retained its own shape memorial property only to a certain extent, not to a conventional way. Okay. So this is one project which we did it with one of the automotive tractor company. So basically, they want to fabricate their engine cabinets. So for engine cabinets, so what we made is, so we made some kind of prototypes so that they have a flexibility to change their engine cabinets based on their requirement. So this is what we tried with them. Okay. So the next case study which I would like to talk about is called as a gripper. So basically, we were in the process of developing a gripper for a smart industry 4.0 which deals with silicon wafers, etc. So our gripper design was something like this. So in this gripper designs, basically we have a gripping jaw, and you have a shape memorialized spline over here. So by try to actuate these splines, so your object is get on hold. When I try to cut off the heat, it comes back, and so that you can withdraw your jaw. So this is what an idea. So basically, kind of a gripper off and a gripper on, which we employed for our system. So now here the major challenge is again getting these SMA splines in an outside market is not at all possible. So only option what you have is you need to print these structures based on your requirement. Second thing is your structure, what you are printing should have a visible actuation. So that was the major challenge which was lying in front of me. So what we did basically is, so we fabricated almost these. So earlier we were using laser additive manufacturing, but somehow we had some issues with respect to the porosity. So what we thought is, why can't we develop our own unit? Because commercially, if you see, you can get shape memory alloy wires. So what we thought is we can develop a shape memory alloy wire based additive manufacturing, which we call it as wire arc based additive manufacturing. So this wire arc based additive manufacturing is an interesting system. In fact, this unit which we have developed in our laboratory at a lower price. In fact, we have developed this for cost of something around 3 lakh, which includes the software. And now we are in the process of selling it from IIT Indore, kind of technology transfer to many education institutes. So this unit, we almost dedicated it only for shape memory alloy based system. So in fact, we went for a wire feed shape memory alloy. So we fed the wire, and we have a proper precise manipulator over here. So this manipulator was moving, and so that we can build the structure. In fact, this is a video which was taken during the fabrication. This is a kind of structure which we have developed in our lab. And you could see that the current system has a capability in such a way that you have a heating bed. So this heating bed has a capability to manipulate, and then you can build any kind of structure on no problem. So you can manipulate your cursor structure. So that is an advantage of going for this system. And we have a capability to build up to 30 centimeter by 30 centimeter area using this unit at a very low cost. Okay. Now comes to the performance. So this is the as fabricated NATA structures which we have fabricated. So we want to use it for a kind of this one gripper. So in fact, we went for a complete wire idiom. So using a wire idiom, we have diced it. So this is the pseudo elastic NATA. Then we went for a training of these martensite structures. So then we apply a stress to this to get a D-twin martensite. When you try to put it on a hot plate, it comes back to the martensite. So basically, so we went for a complete training capability over here. So in the case of a training capability, so that to achieve the required operation which is being employed. So these are some of the characteristics which we did, so which already you are exposed to. Basically, I want to know what is the austenite phase and the martensite phase, and based on that, I can use it for my application. Okay, and we went for a mechanical process in it. But the major challenge in this setup is, see, I am fabricating it in the form of a bulk. Then I am dicing it into a form of a strip, which I felt that somehow I am not justifying the additive manufacturing. Because the main objective of additive manufacturing is, we all know that you are trying to reduce the material loss. Okay. So here, almost it is something like additive, subtractive, and then I am using it. So what we thought is, why can't we employ a system? So in fact, this is the additive manufactured sample which we have used it. So this is a recovery which we have studied. So this is almost kind of a 80% recovery which we have achieved with respect to additive manufacturing system. So we backside there is a hot plate is there. So with respect to the hot plate, we were trying to study that. Okay. So as coming back to the story, so like so first we are just doing an additive and then we are going for a subtractive. So basically it is not worthwhile to use it. So what we thought is, why can't we make a thin layer? But we attempted with this machine. Somehow this machine capability didn't allow us to go for a thin of around 1 mm thickness material. So when we try to probe into it, we came up with an idea. So this idea is quite interesting, that you use a laser. When you try to use a laser on the material and when you go for a marking, so you have a welding gun which is available. So this welding gun, wherever you have done a marking, so it will try to pull the energy in that particular, or it will try to concentrate the energy in that particular region so that you can make thin sections. So this was highly interesting for us. So we thought of employing this idea for making thin shapes. In fact, this is an attempt what we made in our lab. So this is the layer width of around 3.5 mm with the process parameter without marking, and we could achieve a width of around 1.8 mm after marking. So even we could achieve a thin sheet. So we went for a complete analysis. So first thing what we did is we did a marking, and then we went for a deposition. So these are something kind of a laser marking which we have employed. So we used almost a kind of a 50-watt fiber laser. So this 50-watt fiber laser was fed into this wire arc additive, and then when you try to process through it, so you can have a detailed deposition coming out. So this is a kind of contact angle measurement which we have employed. So in this contact angle measurement, what we made is basically, so it helps us to understand how much is the wettability behavior of the system works. So basically, it helps. You have a water droplet. Through the water droplet, we can just study. So we went for a complete detailed temperature distribution, and we went for a complete theoretical analysis to study how the temperature distribution happens with respect to the variation in the laser processing. So this is an XRD analysis which we did, because here, since I am doing a kind of a laser marking, so obviously there is a chance for me that by employing such kind of laser marking, so I can just tune my crystal structure which is being employed over here. So that is one major aspect which we have attempted over here. So we went for a complete theoretical analysis. So this is a VAM sample without marking, and in fact this is with marking. So this will give you a better clarity how the surfaces were made. In fact, we went for different layers, like almost we built different layers. We went for a different layers so that you can build the layer, and we were also trying to see how the layers were working upon. In fact, we went for a different layers and we were trying to study the hardness capability in detail with marking and without marking. So this is a multi-layer hardness. So this is a multi-layer track which we have prepared. So with respect to this multi-layer track, we were just pinpointing how much is the hardness variation, which is connecting my system. Okay, so this is one arrangement which we made. There is a concept called laser actuation, laser-based actuation, because since you are using a heat for actuating your shape memory alloy, so we thought, why can't we use a laser for actuating these materials so that it becomes a non-contact based actuation. Like for example, I have a nuclear reactor. So inside a nuclear reactor, there is a relay and there is a valve. So I need to use a system to on and off the relay circuit. So in order to on and off my relay circuit, so what basically I am doing is, so I am just using my laser to heat it. So when I am trying to use the laser, so there is going to be a flipping arrangement, and this flipping arrangement will try to help me to move back. So that is what an idea which we made over here, and by actuating it, we could able to see how the things were working upon. Okay, so this is a setup what we made in our laboratory to study the overall life cycle analysis. So because after you do non-contact based actuation, there is a chances there that it may lose its property. Okay, so for that, in order to test that, we took the laser actuated sample and we went for a complete actuation analysis, and we observed that the recovery ratio was not changing much. In fact, there was a change in recovery ratio from 80 to 70% value, which was comfortable enough. So the last session which I would like to talk about is, so slightly let us push away the shape memory alloy there is one concept called piezoelectric. So this piezoelectric is quite an interesting area. So most of you might be aware about piezoelectric. Like these are some kind of intelligent crystals. So when you try to apply a pressure to it, so you get an EMF which is being generated along the sides. So this is what an idea of a piezoelectric structure. So what we are attempting is, like you have a machine tool, you have a machine. So any machine, when you try to work, there is going to be a vibration. So we are going to harvest the energy from this vibration so that you can potentially make a sustainable system. So that is one idea. Second idea is basically we were in the process of developing some kind of piezoelectric based steward platform. So a steward platform is a part of a parallel manipulator. So basically, like people, when you go to malls, there is some kind of video games which are available where your kids used to sit on a bike and your bike moves. So those underneath there is a platform. So that platform acts as a simulator. Okay. So now when we try to come back to manufacturing point of view, for example, if I have a sample something like this, I want to drill a perfect hole. So if I want to drill a perfect hole, so the only option which is available is with me is, so when I just lock my sample. So when I try to lock my sample, the sample will not move. Then I go for a drilling. But here I'm arresting the vibration. So when I try to arrest the vibration, still there is going to be some kind of error which is going to happen over this region. So in order to avoid that, what you can do is, so this is your sample. So you can just mount the sample over here, and this is being embedded with a piezoelectric. So when a drilling is being employed over here, there is going to be a vibration. So your vibration is something like this. When I give an opposite vibration, then you can nullify the vibe. When I give an opposite signal, then obviously you can nullify the vibration. So this is, so your piezoelectric has a capability to do that. It can take up the vibration signal and it can actuate it in an opposite vibration so that it can nullify the vibration coming out. So this is what an idea what we are working upon. So as far as piezoelectric is concerned, so one important aspect which I would like to say is this piezoelectric commercially which is available has a lead in it, so which is harmful to the environment. So normally people are not interested to use it. So so what we, in fact, it is not biodegradable also. So in our lab, so we have developed a biodegradable piezoelectric structure using zinc oxide based system. So making it at par with the conventional one. In fact, I'll be just showing a video where we have harvested the energy from a compressor. So we have, so it's a kind of a sticker kind of arrangement what we make. So we have just pasted it on a compressor. So when so this is a simple arrangement where a person is tapping and he's trying to harvest the energy. In a similar fashion, this we have fabricated in the form of a sticker and we have pasted in a compressor. When a compressor vibrates, so we can harvest the energy. So that video I'll be showing it to you. And this is a small burglar alarm which we made. This video is not working. So in this, we have made a mat kind of arrangement. So in this mat, so when someone steps in, so automatically it gets energized and then it creates an alarm. So you don't require to connect it to a battery. And this is a kind of a fluttering device. So basically you have a kind of flag kind of arrangement. So in this flag, we have integrated piezoelectric structures. So when the flag flaps, so you can just harvest the energy. So I think I'll be showing you this video. And this is a kind of self-energized smart gas purging system. So how much ever you stamp on it, you can harvest the energy and you can use it for your application. So before closing, so I would like to show a small video about our laboratory and some of the experiments which we have done. Hope you could able to see my video. Yes? Could you able to see my video?
Sir, not well, sir.
Okay. 1 minute. Is there any?
The page is been open, sir.
Okay. Now, could you able to see a window?
Yes, sir.
Okay, good. So these are some of the facilities which we have. So we have a high laser facilities, which is of high power as well as low power. Recently, we have also developed a micro 3D printing unit. In addition to that, we also have a complete characterization facilities like DSCs, differential scanning calorimetry, temperature control UTM. And then we have a strong thin film facilities. So these are some of the additive manufacturing unit which we have developed. So this is a metal additive manufacturing unit which we have developed in-house. So these are some of the structures which we have fabricated in our lab. So in fact, I would say on an Indian context, we are the first to develop an additive manufacturing dedicatedly for shape memory alloys. So we have a capability to print shape memory alloys around 30 centimeter by 30 centimeter area for any kind of applications. Either it might be pseudoelastic or any kind of other one. So this is how our additive manufacturing unit works. So basically, it's a completely integrated inside a glove box, so that you can have your control over the impurities. Second thing is here we have kept a hot plate which has a capability to heat up to 650 degrees Celsius. So when you have a capability to heat up to 650 degrees Celsius, so you can have a refinement in your granules, and you can have a control over your crystallized structures. Okay, so this is a shape memory alloy. In fact, welding of shape memory alloy is a challenging task. So which we have done, we have performed in our laboratory using a friction stir welding concept. And using this friction stir welding, we are just actuating it, and we are trying to see its behavior. So this is a complete 3D printer structure which we have developed in our lab. And this is a laser displacement sensor which is used for studying the life cycle behavior. So this is a laser actuation which we have employed. In fact, on an Indian context, we are the first to go for laser actuation. So this is called as laser forming, which is a kind of a die-less manufacturing. So this is a trial which we have done it for a company called John Deere for making engine cabinets. So you can see a bending, and this is how we have applied a constraint to it. So interesting part with this laser forming is you won't have a spring back effect. So this is a setup for laser short pinning. Basically, to induce a compressive residual stress. So this is a kind of a shape memory alloy embedded composite structure. So in this shape memory alloy composite structure, this we have developed for some of the handheld missiles for DRDO. So we have transferred this technology for DRDO for some kind of maneuvering applications. So this is called as SMA heat engine. So which has a capability to harvest energy in a completely hot environment. So it comes under the category of the perpetual motion. This is called as a shape memory alloy bimorphs, which we have developed in-house. So basically, these shape memory alloy bimorphs can act as an actuator for some kind of soft robotic systems. So we have a capability to fabricate these shape memory alloy bimorphs in the order of 1 meter by 1 meter area. So if any one of you are interested, I can just prepare it and send it to you for certain amount of experiments. So we are also involved in some kind of soft robotic structures. So this is a SMA powered jellyfish, which we have developed in collaboration with one of DRDO lab. So we have a testbed tank, and the idea behind this is basically for going for underwater condition. This is a SMA actuated robot, so which was also developed with the Ministry of Earth Science. So this is a lead-free piezoelectric structure which you have made for it's a kind of a self-energized system. So how much ever you stamp on it, based on it, it harvests the energy, and that energy is used for this reaction process. So here there is one of our research scholars. So he has developed this structure. His name is Rajagopalan Pandey. So he is just stamping on it, and he is doing the reactions. So this is a burglar alarm which has been set with a piezoelectric structure. So when person stamps on it, automatically whatever energy which is being generated with respect to an alarm ons. So these are some of the jugaad work which our students have did. So this is quite an interesting thing, which is something like I have a fluttering device. From the fluttering device, I'm trying to harvest the energy. So like, for example, you have a flag. So in a flag, you are just trying to integrate these piezoelectric structures so that wherever in the kind of remote location where a huge amount of air is there, so with this fluttering flag, you can harvest energy. So this is a wind tunnel experiment. We have done it for harvesting the energy. So this is the piezoelectric based machine tool monitoring technology. So this is a small compressor where we have pasted the piezoelectric structure. One interesting part in this is it not only used for harvesting the energy, it is also used for monitoring the system. And like whenever a machine is going to fail. So obviously, with respect to by minutely understanding the vibration, you can study how when the machine is going to fail. So that is an interesting aspect with this system. Okay. So with this, I would like to close my lecture. So I'm free to answer any kind of queries or questions.
Thank you, sir. Thank you for the valuable presentation you have given us. And participants, if you have any queries, kindly unmute yourself and you can interact with the speaker. Participants, it is your time now.
Hello.
Yes, sir.
Sir, good afternoon.
Good afternoon, sir.
Sir, this physioelectric, whatever you are using the physioelectric material, can we extend that to generate the electricity for domestic applications?
Sir, you are in unmute, sir.
Unmute. Okay. Could you able to hear me?
Now I can hear you, sir.
Okay, okay. See, as far as direct domestic application is concerned, so taking that much load will be very difficult. But you can go for a localized power source. Like one example I will tell you. So currently we are working with one project with DRDO. Like for example, we are trying to integrate these piezoelectric under the sole of the soldiers. So when they walk, so how much ever it is getting charged, so we can just they can just charge their mobile phone. Okay,
yes,
so
yes.
to that level we can use it, but for running a kind of a fridge or kind of domestic appliance, it is very difficult because whatever you are getting is in the form of a DC. So so that is one major thing which we are working upon. But otherwise, for localized charging, it is possible. In fact, one more example I would like to say. For example, you are talking about this underwater systems. So in an underwater system, charging a system is a major issue. So we are trying to integrate this piezoelectric on these underwater systems so that when it goes down in an underwater condition, because of the loading, so your system gets charged and then you can charge your sensors. So your individual sensors will act as a localized source which can be charged using. So this is one. So in fact, there is an area called triboelectric which is coming up in this particular domain.
Thank you, sir. Thank you very much.
Any other queries from participant side?
Okay, so if not so, you can just write to me. My email ID is palaniya@iita.ac.in. So I'm just posting it in the chat box. So people who are interested can write to me so we can go for any kind of collaborations.
Thank you very much, sir. Thank you, Palani, sir. Thank you very much, sir, for came over here for presenting your wonderful keynote lecture in our ICMSD conference 2020. I thank Dr. I.A. Palani, sir, Dean Research and Development, Indian Institute of Technology, Indore, who delivered the lecture topic on laser and smart materials key elements in advanced manufacturing. Thank you very much, sir.
Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Participants, I have an information for you all. Please go for the lunch and you come on your scheduled presentation. Your presentation link will be on Google Meet. The Google Meet link is available in our website ICMSD.org. ICMSD.org. You find on your schedule available there. Please welcome. Thank you.
Yeah, thank you, sir. Thank you, Purushottam Kumar.
Okay, sir, we can wind up.
Stop பண்ணிக்கணும் Facebook live session stop.